Well, thank you very much. I appreciate that.
I was reading it this morning. It was like reading a physics book. Stretched my mind a little bit.
So some of the cosmological stories are a bit dense, and people love them that way, you know. But
Oh yeah, fascinating stuff.
well, thank you. We have a big year coming next year. The magazine will be 50 years old, so we have a whole lot of special things planned next year.
Years old.
Oh, and Scott, are you there?
Yes.
That reminds me of something I casually mentioned to a couple of the editors, and we can't do it like next week, but I think there's interest from the editors in doing a magazine sponsored version of the Star Party again at some point.
Cool. Great.
Maybe later this spring.
Yeah. We'll have to pick an auspicious day, you know, where something that, you know, maybe, well, they get to pick the day, the subject, the speakers, the everything.
Okay.
It's awesome.
It's good to see you up and about. Did I what?
Feel bad. We're all being quiet. Our microphones are hot, but we've got no video.
Oh yeah,
playing
because
at
I
home.
said the microphones are hot.
Yeah.
So everybody's like, well, I don't want to say anything. That other
Nobody even
people
said
might
hi
hear.
to Daniel when he joined. Hi, Daniel.
I just got together here, so.
Oh,
How's
Terry,
it going?
I wanted to tell you, Happy International Women's Day.
Absolutely.
Thank you.
Yeah, there you go. I also heard it's International Peanut Cluster Week or something like that. Is that right?
No, it's
We-
Scott, it's I can see on Facebook here, it's National Peanut Cluster Day. And
Nice.
the slogan goes, melt the chocolate, add the peanuts, and stir them together. It's just that easy.
Well, then, David, I assume you're going to make some and send it to all of us.
Yeah, I have to. I'm going to have to
Right.
schedule that for next week, I think. Yep, I'm unprepared tonight. I had no idea somehow that it was National Peanut Cluster Day. I've dropped the ball entirely.
I think we're going to have to tie in today's mineralogy to peanut clusters.
Yes. Well, these are even, what I'm going to show is even crunchier than peanut clusters, I'm afraid.
Yeah, that's right.
Oh, Pepper, a dog. Go on out. Oh, that's pretty.
This
interacting galaxy duo called ARP-143 holds the distorted star-forming spiral galaxy NGC-2445 at the right, along with its less flashy companion NGC-2444 at the left. Astronomers think both galaxies pass through each other, igniting the unique triangular-shaped firestorm of starbirth. Because NGC-2445 is rich in gas, the fuel of star formation, it holds thousands of infant stars. Yet it hasn't escaped the gravitational clutches of its partner. The pair is waging a cosmic tug of war, and NGC-2444 appears to be winning. The galaxy has pulled gas from its companion, forming the oddball triangle of newly minted stars. By studying head-on galaxy collisions like this, we can better understand the origins and evolution of ringed star formation in galaxies.
Well, hello, everyone. This is welcome to the 85th Global Star Party, Expanding Universe. You know, our knowledge of an expanding universe started in the 1920s, and we are still trying to understand the universe that we live in. But part of this expansion also is the expansion of our own knowledge and our awareness of our interconnectedness with everything that's in the universe. And so tonight we have just a really amazing lineup of speakers, as we normally do for Global Star Party. Just to kind of cover it a little bit better with you, we have David Levy that's starting out. We'll have Terry Mann, who's coming on from the Astronomical League. David Eicher, the editor-in-chief of Astronomy magazine, is with us once again. Dennis Coy from Yerkes Observatory will be giving us an update. Karim Jaffer from the Royal Astronomical Society of Canada in Montreal. Francois Quesnel from an astronomer in Quebec will share some of his night sky photography. We have Daniel Higgins from AstroWorld TV, who was on last Friday with us. Steve Edberg, who's a professional astronomer, planetary scientist, now retired, is joining us to talk about a redshifted universe. John Johnson from the Nebraska Star Party will be with us. Then we go down to Brazil with Marcelo Souza. We'll swing back up to the USA with Adrian Bradley. Glenn Roberts will be attending, and Maxi Falieres, astrophotography to the max down in Argentina. So we will switch now to David Levy, your friend and mine. And it is a pleasure to have you on today, David. Thank you for coming on to Global Star Party.
Thank you, Scott. It's good to be here. Excuse me. Try that one again. It's good to be here. And we hope we'll have a world in the next few weeks that we can continue to do these global star parties from. Today's quotation is going to be from Charlotte Bronte. And I'd like to make the claim that, in my opinion, she may be the greatest writer in English after Shakespeare. The quote today is from Jane Eyre. And those of you who are familiar with the book will remember that her first meeting with Rochester comes when she spooks his horse. And he isn't the most polite man to her about that. He sprains his ankle, he rushes back, and then Jane goes back quietly on her own. As she's about to enter the house, She has an observing session that I would like to quote now. I lingered at the gates. I lingered on the lawn. I paced backwards and forwards on the pavement. The shutters of the glass door were closed. I could not see into the interior, and both my eyes and spirit seemed drawn from the gloomy house, from the gray hollow filled with rayless cells, as it appeared to me, to that sky expanded before me, a blue sea absolved from taint of cloud, the moon ascending it in solemn march, her orb seeming to look up as she left the hilltops, from behind which she had come, far and farther below her, and aspired to the zenith, midnight dark in its fathomless depth and measureless distance. And for those trembling stars that followed her course, they made my heart tremble, my veins glow when I viewed them. Little things recall us to earth. The clock struck in the hall, that sufficed. I turned from the moon and the stars, opened a side door, and went in. Thank you, Scott.
Thank you so much. Thank you, David. You know, David alluded to the problems that we have going on in the world right now, but you know, I think that it's important to recognize that astronomers, in particular, I think, are often join each other and collaborate with each other from all over the world. And you know, the effect of looking up and seeing one sky and understanding something beyond our borders and what divides us is incredibly important. If there's nothing else to learn from your interaction with astronomy, you know, I think the most important thing to learn is that we are all we all share this one little pale blue dot, this one planet, and we're here to help each other, you know, and not to worry so much about what we have or what we don't have, you know, because it's you know, it is really our duty to make it all work and to share. And if we do that, we'll all be just fine. So
Actually, Scott, I agree with what you said, except when you said it's our duty. Instead of duty, I would say it's our privilege to be here to look up at the night sky.
I would agree. I would agree.
But while we're agreeing, and thanks, Scotty, while we're agreeing, I'd like to mention a couple of things that are coming up later in the year. This late September, Explore Scientific will be conducting an Arizona Star Party. If you're interested in coming, and I hope you are, please get in touch with Scott Roberts at Explore Scientific, Explore Alliance. He can tell you all the details. And the other thing is that coming up on the 21st of May, a group of us are getting together with the Coconino Center for the Arts in Flagstaff in order to celebrate the life of Carolyn Shoemaker. And so you may be interested. Those two events I did want to point out to you. And finally, back to my friend Scott.
Thank you, David. Thank you so much. Okay. Well, it's you know, it's once again a privilege to do these things with David. I count each one of them as a blessing because it's just such an honor. So, David, thank you so much, man. The Global Star Party and Arizona Dark Sky Star Party that will happen at Oracle State Park in Arizona starts on September 21st and runs through the 25th of September. So we will be putting out more information as that comes along here. But right now we are going to go to the Astronomical League. We're going to introduce Terry Mann. Terry is a former two-term president of the Astronomical League. She's been with the Astronomical League for many years, tirelessly supporting astronomers throughout the you know, the Federation of Astronomy Clubs and members at large, and there's just so many tendrils and aspects to the Astronomical League that supports our community, and you should be part of it. You should join an Astronomical League club or join as a member at large. You can do that through astroleague.org, but they have over 300 clubs. They have over 20,000 members, and it's an all volunteer group that does this. So it's wonderful. And I'm glad that the Astronomical League works with us the way that they do. And here you are, Terry, all yours.
Thank you, Scott. I'll get ready to share my screen here. Okay, so I will start with the questions. We always open with a warning about viewing the sun. You always have to make sure that you have the correct filters on your telescope or on your binoculars, whatever you use. We want to keep everybody safe out there, especially knowing we've got 2 eclipses coming up in 23 and 24 that many of us are already talking about and starting to put plans together for. So always ask somebody, especially if you're new to astronomy and you want to look at the sun, please ask an adult or somebody in a club before you ever start observing the sun to make sure you have the proper filter to do that. So I'm going to start with the answers way back from February 22nd. It's been a while since we've been here. And so here are the questions and answers. Discovered in 2005 and initially thought to be a new major planet in the solar system, this object was initially named Xena. What was the name? And it is Eris. Second question, Edwin Hubble made his seminal discoveries of the existence of other galaxies and the expansion of the universe using a telescope with what aperture? And that's the 100-inch Mount Wilson. At 8 p.m. on January 26, 2022, I observed a large dome of light extending from the southwest horizon in Aquarius all the way to Aries near the zenith. What was I seeing? That would be the zodiacal light. That is, it's really something to see. This was not me saying this. This was Chuck Allen's questions. And those are the answers for the 3 questions from the 22nd. These people, Adrian Bradley, Don Knabb, Rich Kraling, Josh Kovac, Michael Overacker, Andrew Corkill, Cameron Gillis, and Rich Eubank answered the questions correctly, and they were put on the door prize list. And since this is the first star party that we are doing for March, I want to announce the winners of the month of February. And again, that would be Josh Kovac, Neil Cox, and Paul and Kathy Anderson. Somebody from Explore Scientific will be in contact with you. And so the questions for March 8th, and this is totally me. March is Aurora month for me. So we're going to talk about the Aurora and ask some questions. Depending on your location, you might be able to see the Aurora at different times during the year. Statistically, there are 4 months when the Aurora is more active. Would that be A, March, April, September, October, or B, February, March, August, or October? C, January, April, October, and November. Which one would you choose? The northern lights are formed by charged particles emitted from the sun during a solar flare, penetrating the Earth's magnetic field and colliding with atoms and molecules in our atmosphere. These collisions result in little bursts of lights called photons, which make up the aurora. When photons collide with oxygen, does it produce red and green aurora? True or false? And the last one, can coronal holes on the sun cause the aurora? And please join us this Friday. We have AL Live coming up, and our speaker will be Mike Shaw. Mike is from Minnesota. He is a landscape astrophotographer, And he will talk about getting started in landscape astrophotography. And as always, we'll have Carol, myself, Scott, and David, and we appreciate everybody. And we will also have an update on Alcon 2022 with Jim Fordyce. He is the chair, I do believe, of Alcon, and we will be live in Albuquerque this year, July 28th through the 30th. We'll get the latest details. This has been postponed now for 2 years, so we are all really looking forward to the details for Alcon 2022. I hope you can join us for that too. And I should go back and say, send your answers to secretary@astroleague.org for the questions. So thank you, Scott. I appreciate it.
Wonderful, wonderful. Well, Terry, thank you so much for coming on. And we look forward to the Astronomical League live event. Is this the 7th or 8th one that we've done so far?
Oh, no, this is, I think this is the 15th.
15th one.
Yeah. Okay, Scott.
It went so fast. I don't know, you know, so.
It does. It goes by so fast anymore. It's like, it's
Oh,
summer
yeah.
almost.
Yeah.
Yeah.
I look at some of the shows we've done and, you know, we're now into the hundreds of shows that we've put on for various things. So
I look at Global Star Party. My gosh, it's hard to believe. I remember when you first talked about doing this.
yeah,
I mean, it has just flown by, and we've met so many great people and learned so many things from everybody. And, you know, it's just added to the astronomical community. So, you know, it's really been a good thing. It's been a really good thing for expanding everybody's knowledge and fun.
Right. Yeah, absolutely. Terry, thank you so much.
Thanks,
Thank you.
Scott.
Okay, so up next is David Eicher. David,
Or
if you
David
don't,
Storsa, can I say something?
oh, sure, sure.
I kind of like to get in a dig before David gets going. We really look forward to him. But I was especially impressed with Terry's presentation just now. The Astronomical League is meeting in Albuquerque this July. I hope to be there. And also wanted to say that the Astronomical League has become very active in a new group for children called Cosmic Generations. I think Karim's going to talk about it later, but there's going to be this Sunday a meeting of Cosmic Generations, organized, run, led, everything by the kids. And I just wanted to say that, and I'm sorry, David.
No problem. No, Scott.
No problem. I did want to introduce David Eicher. For those of you that might be watching that are not familiar with David Eicher, he is the editor-in-chief of Astronomy magazine, which is the world's largest circulation magazine devoted to astronomy. It has more readers than anyone, and they're coming up. I don't know the exact date yet, but they're coming up on their 50th anniversary. So their devotion to the worldwide community of astronomers is really impressive. And David Eicher's been there for a lot of it. So it's a real privilege to have him on the show. David not only has a passion for astronomy, but he has a passion for minerals and crystals amongst his other passions. This is a guy with multiple interests, and he's always fascinating to listen to. You know, he always makes it fun for us no matter what we're talking about. But David, it's all yours.
Thank you, Scott. And next year will be the 50th anniversary of astronomy. And at the end of this year, I will have been at the magazine only for 4/5 of that time.
Wow.
So time flies when you're having fun, huh? So I will share my screen and see if I can get a slideshow going and see if I can start the slideshow and go through some more minerals. We haven't gone through the entire landscape of planetary geology yet, but we're getting there. And someday I'll move on back to more astronomical things that are a little more straightforward. But of course, minerals are the way that the universe assembles planets. And so this is interesting because although temperatures and pressures and other conditions would change, of course, dramatically from place to place in the universe, within galaxies, within planetary systems that we know are out there ubiquitously now. The chemistry of the universe is universal. We know through spectroscopy that the same elements are throughout the universe in the same way. So these things kind of show us the way other planets might be as well. Well, and we know now at this day and age that we don't need supernaturalism to understand the universe. Thomas Jefferson, a great hero in some ways, said, "I believe in a divinely ordered universe." Even before his time, Isaac Newton, one of the founders of modern science, if you will, said, "Truth is ever to be found in the simplicity and not in the multiplicity and confusion of things." The universe is ordered not by supernatural design, but by the principles of physics that demonstrate how the universe works through physics, chemistry, and the rest of the sciences. Minerals demonstrate this in that their atoms are assembled, not magically, but in precise ways by electrochemical attractions, inherent properties of the atoms that make them up and guide them into assembling into what mineralogists call a specific crystal lattice, a form. And we can see that, of course, in all the mineral specimens that we look at. And there are about 5,000 minerals on Earth altogether, about species, as they are called, different kinds of minerals. And a lot of them, and we'll look at one of them today, are so-called hydrates that incorporate water into the minerals, into the crystals. And dioptase is one of them. That's a very attractive copper silicate oxide hydrate. You can see the formula there. It was named in 1797 by the great French mineralogist and the more or less the creator of the modern understanding of crystallography, René Huy. And it was sort of inspired by the words through and to see, an allusion to the visibility of the mineral's internal cleavage planes. It comes normally in a sort of a vibrant emerald green color, which you'll see, or blue-green. And its crystals are normally rhombohedral, and they're usually elongated, and they typically are less than about 3/4 of a centimeter in size, and sometimes very, very small, as you'll see. So this is yet another one. The largest family classification of minerals of all are the silicates, of which there are many, 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 because silicon making up a good part of the crust of Earth is very common. And oxygen, as we've talked about already, likes to combine very easily with practically everything. So here's a diagram of the crystal structure of dioptase. It's trigonal, a 3-field rotational axis here, and you can see the different colors of the atoms there making up a crystal. And I'm also going to show, by the way, a couple of sort of related minerals here with this as well. And I have to apologize, but I'm getting into the part where the groups of mineral photos I have are kind of by shelves here and there a little bit. So there are going to be a few minerals with a couple of other related minerals thrown in there. So again, I just thought I would show you the variety and sort of the appearance of some of these minerals and how they look. So here is dioptase, which is the emerald green, with shatukite, which is this blue mineral at the base of this. And this is a big hefty piece from the so-called Katanga copper crescent in the Democratic Republic of the Congo in Africa. This is a region that has a lot of interesting minerals and is very, very well known for having many, many radioactive minerals as well, and is an important source of uranium, this area, among other things. Here's a sort of a typical dioptase piece that is from one of the major deposits of more recent times. A huge amount of stuff came out of this area in Kazakhstan. And so this is a fairly common area for mineral collections to have a piece of this in. Here's a somewhat older time dioptase piece, and you can see that this sort of emerald color is usually pretty typical of these crystals. The Sumeb mine was mined for the better part of a couple of 100 years now, with Germans going and exploring down into Namibia and finding this mining area. So this is an older piece, presumably. Then I've thrown in a related mineral or two as well here, as I said, that we're kind of stuck together in the photo groups with these. This is broshantite, which is copper sulfate hydroxide. And this piece, it's similar in color. And you can see this has these sort of needle-like crystals, but it's somewhat related in that it's a copper hydroxide. And this is from the Grandview mine, which is actually within the it's adjacent to and within essentially the land of the Grand Canyon, believe it or not. Here's back to Dioptase, a famous mine in Arizona, up in the mountains, the Dripping Springs, the Christmas mine. And this is sort of a more typical piece of what you would find throughout. Here's back to broshantite, and these are very large, impressive crystals of this copper mineral. Copper, of course, gives this both these minerals the strong green color. And this is from a very famous mine of recent times, the Milpitas mine in Mexico, that has produced a lot of good specimens. I mentioned some of the crystals of dioptase are really tiny and like a sort of a coating of very small crystals, submillimetric crystals, if you will. And this is the case with this piece that's a Chilean sample. As opposed to that, these are big blocky crystals here and back to the Katanga region of the Congo for this. And you can see these are kind of chunky, big crystals of the same chemistry, of course. Here's dioptase from that famous Christmas mine again in Arizona that is on calcite that gives it a little bit of a different look.
Beautiful.
And back to broshantite here from Morocco. This is a sort of a big piece, but you can see it has the same basic look more or less, even though the pieces are a very different character. This is broshantite again in these needle-like crystals, again from Mexico. And very similar acicular needle-like crystals of the same mineral, this time from Morocco. And I've thrown in a couple of smithsonites, which I talked about previously, zinc carbonate, which also have a little bit of copper in them here to color them, are thrown in here too because they were adjacent to the groups, and some smithsonite with rosacite here from Utah, Tooele County, and some smithsonite back down from Mexico as well. And you can see how these minerals that are sort of related and they're all influenced by copper color are sort of nice display pieces, and they show a pretty good variety of form in what we find on Earth. And I thought I would mention again, Scott, very quickly, and this is something
Sure.
that Explore Scientific is going to be involved with, and we can hope that there's peace in Europe before this occurs in the fall. This will be September 5th through the 10th, our 6th Starmus Festival, which I'm on the board of directors of and excited to be involved with. And we've had the first round of speakers announced here: Charlie Duke, Nicole Stott, Kip Thorne, George Smoot, Garrick Israelian, Jill Tarter, and even people as undistinguished as me will be speaking there. And we also have Starmus is an international science festival, and we've had about 3,000 to 5,000 people there generally. This year it's going to be in Yerevan, Armenia, the capital of Armenia, the largest city. In the past, we've had quite a number of performers there as well, because Starmus was really founded by a small group that includes the astronomer Garrick Israelian, who's in the Canary Islands there at Tenerife, and his close friend Brian May, who is an astronomer and who's a co-author on some books with me, and who in his spare time also plays guitar. So the idea is that we like to have science and also the arts represented there. And so stars and music, Starmus. And we've had in the past at Starmus's as some rock and roll thrown in there as well, entertainment, as well as the very serious talks from astronauts, from Nobel Prize winners and others. And those musicians have included Brian and Rick Wakeman and Peter Gabriel, Brian Eno, Hans Zimmer, Steve Vai, Grace Potter, Sarah Brightman. There are some very, very important and celebrated popular musicians who will be there, and we'll be announcing many more later as the weeks progress into the spring and summer as well this year. And this year we will celebrate, as one of the major themes, 50 years on Mars. So it was a tad longer now. It was actually 1971 when the Russian Mars 3 and the Mariner 9, the American probe, first arrived at Mars, and we had cooperation among the powers in space, exploring science, and we'll hope to return to that kind of cooperative, positive mood this fall in Europe. And Scott, I know you're going to be involved in a major Star Party event also at Starmus, along with myself and Garrick and others. And Explore Scientific will basically be the engine that's running that big Star Party.
Yeah, it's going to be a lot of fun. I'm really, really excited about it. And I think it will be the biggest event I've ever partaken of. So I'm really honored and a little frightened at the same time.
It'll be a piece of cake, no problem. I promise you. We should have maybe about 1,000 people, or who knows, maybe more at the Star Party.
Right.
Yeah.
It's
So
quite a
we're
few.
Looking forward to that. We hope that you can join us in Armenia. It's actually a very easy place to get to for Europeans. So if you can get over there, it's easy to get to, and we'll hope that we have a peaceful world long before then.
Yes, absolutely.
David?
David,
Yes, sir.
thank you.
Two questions for you, please.
Yes.
Why is this dioptase mined here in the country? What is it used for? Question one. Question two is, did it evolve here on Earth through our geology, or is there signs of it elsewhere in the universe that we can find?
Yeah, it's only known on Earth, and we don't know about mineralogy to a very extensive degree on other planets. Not to get into a long detour, but about 2.6 billion years ago, Earth underwent a huge transformation. And that was the so-called Great Oxygenation Event, when the microbes that were producing oxygen, that most of the history of life on Earth consisted of microbes, of course, and there was a flashpoint 2.6 billion years ago when the microbes that were producing oxygen produced so much oxygen that there was free oxygen all of a sudden in Earth's atmosphere. And that combined and tripled the number of mineral species. And so dioptase, which is mostly mined now for collector specimens, not really as a copper ore, if you will, was one of those oxygenated mineral species. Now, if you go to places like the moon and Mercury and most of the other worlds that we know a little bit about mineralogically in the solar system, there are only a third or less as many mineral species because there's almost no free oxygen there. So dioptase is really known on Earth and should exist all over the universe because there's a hell of a lot of oxygen out there. But in our solar system, it's really predominantly an Earth mineral. Is that a not too long of an answer, I hope?
I think it worked.
Okay.
I think it worked. So, okay. Well, goodness. David, thank you so much for your interesting and beautiful images of these, of the dioptase. And, you know, I love the colors and the shapes and all the rest of it. And, you know, as a kid, you know, certainly I had rock collections and stuff like that, but nothing on the level of what you had. So I'm glad that you could share this with us. And, you know, and you're right. It's certainly a intrinsic part of our universe, and it's good to kind of look down and see what's on this amazing planet of ours. So
Well,
Thanks
thank
very
you,
much,
Cal.
David.
Thank you. I appreciate it.
Thank you. Well, up next is Dennis Coy. Dennis Coy is the current executive director of Yerkes Observatory. Yerkes was opened in 1897, and it has the world's largest refractor there. This was the start of George Ellery Hale's Leviathan, I mean, huge giant telescopes. He built 4 of these telescopes in succession, each one being bigger than the last. But it all started there in Williams Bay. And if you ever go to Yerkes Observatory, you will feel the history of the facility. The telescope itself is elegant and beautiful. It makes beautiful images. I've looked through it many times, and it is. I'm so glad that the Yerkes Future Foundation was established, and that they were able to save the observatory, to save the telescope, and to give it a bright future. And so Dennis is here with us to give us an update of what's going on at Yerkes Observatory. And it's all yours, Dennis. Thank you, man. Thanks for coming on to Global Star Party.
Good evening, everyone. Hope everyone can hear me okay. I'm hiding away in a guest bedroom as my kids get put to bed. So apologies for my pedestrian surroundings here. I was going to share just some images of work that has been going on at the observatory so that you can get a sense of sort of what we've been up to. I know many of you are familiar with it. So I'm going to share my screen here. You know, so I'm not going to belabor sort of what is there. I think many of you know that. But Scott, is everybody able to see my screen all right?
Yes, it looks great.
Great. Okay. So I won't belabor what's there, but I think you're all, familiar. And we took over from the University of Chicago just under 2 years ago. It'll be 2 years this coming May 1st. So we're just coming up on the 24-month anniversary of our time there. Since we took over. And in that time, we've undertaken a lot of fundraising and a lot of work. I think when I saw this group, if any of you were on the call back in, I think it was June or July of this year, we were sort of just in the midst of our summer season of work. And that season concluded. I'll show you some of what we got done, and then, sort of share with you sort of what we're doing now and what's coming up. So, the dome and the refractor remain wrapped. That work in the dome is not slated until 2023 or 2024. So that area is, for the most part, pretty quiet right now. But when we took over the observatory, basically we kind of took over a historic facility that had been, in essence, sort of abandoned in place. There were still a few staff on from 2018 when the University of Chicago had closed it. That sort of dwindled down to one staff member. And so when we took over, it literally was as if people had just sort of gotten up and left their offices, left their files, left their books and folders, just sort of reams and reams of papers and equipment and things. And so we've been working with, this is one of my favorite images of my first day, was the box of 1,000 keys, which we also inherited. And so, I spent sort of the first a couple of weeks getting oriented, and we have since hired a number of staff and brought some folks on, but it really took us some time to get organized and figure out what needed to be done. So this past summer, we spent much of the year doing a significant amount of brickwork using a company called Marion Restoration, which is out of Chicago. They've worked on the US Capitol. They restored the facade of the Metropolitan Museum of Art when I was the chief of design there. They have worked on the Alamo, all kinds of places that are really experts in brick and stone. And so starting with the outside of the Great Dome, but also a lot of the parapets and other parts of the building that just had huge amounts of water and ice damage from years and years and years of leakage and sort of improper use of historic materials and things. So that work has been ongoing and will continue on for several more years as we sort of work our way through the building. So that's kind of where a significant amount of resources and energy are going. You see there on the right, that's the outside of that same dome. So basically every brick, every one of the Roman bricks coming off, the brick, sort of walls behind those, being hollowed out from the inside, which is the image on the left, so they can dry out. Those walls were so soaked with water that every winter they would freeze and spall brick off, and bricks were literally falling into the observatory dome. And so we've learned that brick dries at the rate of 1 inch per month, and those walls are 28 inches thick. So when it is above freezing, which is not often in Wisconsin, it is, we are drying those walls out, and it will take 28 months of dry time. We also did things like ripped off all the parapets, put on, here you see an image of an entirely new roof being worked on. So a whole new roof system was put up. All the parapets and a lot of the terracotta was removed. Pieces that could be salvaged were stainless steel pinned, and pieces that could be salvaged would be 3D scanned and were replicated. There's sort of a 3D printing version of terracotta now by Marion Restoration, and then various pieces had to be rebuilt over the course of the year. Down there at the bottom of this image, you see a new parking lot going in. The observatory never welcomed visitors before, so the idea of that we'd even need a parking lot was a new concept. So installed a new parking lot, installed charging stations for level 2 for vehicles and for Teslas. Put 83 solar panels on the new roof. So that's the new roof with the new solar panels. So it's now fully running under its own power during the summer, not during the winter in Wisconsin. And then also similarly undertook a lot of work on the interior. This is just looking down, sort of a slightly askew image, because I think it was a panoramic, but looking down the corridor at sort of walls that were being repainted, plaster being repaired, stripped back to the raw plaster and repainted. We had conservators in who are experts in stone. There's just, thousands and thousands of square feet of beautiful marble almost everywhere in Yerkes. And so all of that had been, had 125 years of dirt on it, was covered in soot, was rusting from moisture since the building has not had HVAC in its lifetime or humidity control. So all that work was done, and working on things like restoring the original mosaics on the floor. This is one of my sort of favorite, images or stories, because on the left, you can see that ridiculously bright white section, which was the conservator's first attempt at restoring the marble. And, that is the same marbles you see in those little white tiles, right? So it's, it looks like the lobby of a Nordstrom, which is a department store here in the United States. Not what we were going for. So once they sort of found their stride and sort of sorted out how to work on it, the image on the right is, a restored section where it's retained some of the patina of the original, has, been cleaned up a little bit, but, doesn't feel like it was made yesterday either. We're trying to find the right, sort of level of restoration and work on the building. We've been working our way through the interiors. These were originally 2 offices which were separated, where you see that radiator standing in the center of the room. So these rooms are being combined to allow us to sort of bring in groups for lectures and talks and presentations. So a lot of that kind of construction work going on. And some rooms have been completed. On the right is a conference room that's in honor of Dr. David Schramm, who was at the University of Chicago, a wonderful astrophysicist who died in a plane accident a couple decades ago. A donor wanted to name that room in his honor. So, some spaces have been completed and are ready to go, and some other spaces are being readied for public visitation or for use for fundraising. So this is a space about, of course, Olmsted, who designed the landscapes at Yerkes, the grandfather of American landscape design. And his firm designed the 50 acres of grounds that we still operate and run. And those grounds themselves are being restored. So here's a group of volunteers this past summer. We have every month groups come in and take down dead trees, take down trees that aren't part of the Olmsted plan. We've planted several hundred new trees, from saplings to fairly substantial plantings that require heavy cranes and trucks to move the facility back towards the Olmsted plan. So just all kinds of work going on out in the landscape. And way in the back of that image on the left, you can see a old farmhouse that dates from 1897. That farmhouse is being completely gutted and restored this winter, which will allow us to host residencies. So we'll be having, science writers, artists, curators, photographers, astronomers come in and do summer residencies. So we'll have a 4-bedroom home that we'll be able to host folks in for residencies to work with the observatory, work with the public, work with the glass plates and the instruments. So that'll be part of the programming. And these images are literally from today. Here in Wisconsin today, we had a group of 150 high school kids come and clean out old student domes on the property, just do all kinds of, sort of winter pickup and cleanup, and then fed them all pizza. You see them all sitting there on the stairs on the right after their workday. So, some of this is being done through, with high level professional expertise and advisement. The archivists at the University of Chicago, Marion Restoration, the best folks working on web design, social media, construction, all kinds of areas. And then some of it's being done absolutely with volunteer labor and sort of making use of the resources we have in front of us. We have a lot of work going on behind the scenes. This is the Yerkes website that we'll be launching in a couple of weeks. So just to give you a flavor of sort of, what's to come, there's sort of a pretty old school brochureware site. This is all just FPO text. So don't take any of it too literally, but just gives you a sense of, sort of what will be here once that launches in a couple of weeks. So we've got folks working on that behind the scenes. We've got a social media team working on reclaiming the Yerkes social media accounts, most of which were owned by others or by people not associated with the Yerkes at all. So there's, will be a range of activities and events, and we'll be open for tours as soon as May of this year, believe it or not. Wow. So while we still have years of work ahead, we will still be, welcoming the public in. We'll be hosting tours. We'll be hosting events, talks, lectures. We've got the new director, Chevy Humphrey of the Museum of Science and Industry in Chicago, coming to give a talk this June. We've got other sort of women leaders in science we're celebrating as part of thinking forward to the Roman Space Telescope going up in a couple of years. So just sort of thinking about the long play for Yerkes. So that's where we are right now. And I'm happy to sort of entertain any questions or comments or thoughts anybody has as we sort of work our way through this. We still have a great deal of work ahead. We are running a national search right now for a director of science. So we're down to our final 3 candidates who will be coming, flying in the next couple of weeks for final interviews. So that will be someone, a name that I think almost everyone on this call would probably know from among those 3 candidates, hopefully, who will lead the science program and sort out what we're going to be doing with the 2 extant robotic telescopes, what we're going to be upgrading, how we're going to sort of build a program around what relevant, sort of science Yerkes can still do to contribute, either as it sits or with upgrades. So a lot of work still ongoing. So questions, comments, Scott, anything?
Yeah, there was a question. There are lots of comments like, congratulations on the progress of Yerkes. It's wonderful. I mean, it's really, does my heart a lot of good to see so much care being invested into that observatory, because it's, this is the start. I mean, you can draw a direct line from that to the latest science that's being done today in space exploration and planetary science. So, there's and when you go to Yerkes, you're going to learn this firsthand. So it's important that you make that journey to this place when it comes open in this year. So there was a question if there is a Jim's Astro watching on YouTube, maybe a little tongue in cheek, but he wanted to know, is there a time capsule at Yerkes? So the whole thing is a time capsule.
That's a good question. Yeah, I feel like that's a facility we own, is the time capsule. But maybe we should add one in. We have not found one in anything that we've taken apart yet. Although we have fantasies about doing various different sort of time capsule exhibits. I mean, one of my favorite things that's floated to the surface is we have, I think, somewhere in the neighborhood of 300 abandoned PCs and Macs that were used over the last 30 years at Yerkes, 40 years at Yerkes. I know nobody wiped those hard drives. So I would love to, partner up with a tech museum in San Jose, California, download the contents of all those hard drives, do word clouds and searches. Yerkes was working on JPL contracts, Defense Department contracts. There's got to be some fascinating stuff on those hard drives, and they've just been sitting there for, a long, long time. So there's all kinds of time capsule opportunities for sure.
That's awesome. That's awesome. What do you think? I mean, Dennis, I mean, you've been working on this. How long have you been there now? Has it
I've been
2
there only
years?
10 months.
10 months. Okay. Okay. So your experience, now I know that you have long experience with museums and curating artifacts and this kind of thing, but what do you think is what is the most interesting part of Yerkes to you personally? And what do you think is the biggest challenges that face
Well,
Yerkes?
I think the biggest opportunity and the biggest challenge are kind of one and the same, which is, the goal for us is to create a site that really is like a pilgrimage site for anyone who's interested in astronomy, science, space, discovery, big ideas, the philosophical history of science. I think there isn't anything really like that in the United States. I mean, you can visit wonderful NASA sites. You can go, probably the most analogous site might be Lowell Planetarium, Lowell Observatory down in Arizona. But, we really want to cross-pollinate it through arts, culture, music, science, hard science. And I think that's the opportunity. I think the risk is also finding the right balance in those things and making sure that the work we do is respectful to the legacy and the history of that site. There were some amazing, you all know the names of the scientists who went through there, from Hubble to Sagan to Otto Struve to Nancy Grace Roman to, Chandrasekhar. It's an incredible who's who. And so we need to make sure that whatever we do is respectful, even as it kind of takes it to a place that I don't think a lot of observatories have gone as far as their public program, and being much more ecumenical and broad in the kind of offerings we provide. So that balance, I think, is both the opportunity and the risk, and the thing that keeps me up at night.
Right. Okay. Well, that's great. Dennis, I thank you. I know you're taking family time out to do this.
My pleasure. Happy to.
And so it's wonderful to have you on, and thanks for taking the time with us here.
Well, hopefully we'll have a chance to come back and report again this summer in the fall. And
sure,
we're fundraising's going well. We've, we're all privately funded at this point, and so have raised $13.5 million of our initial $20 million goal, which will then become a next $20 million goal. So that will kind of be an endless process, but things are moving along well. So fingers crossed.
So Dennis, where should people go if they'd like to donate some money towards Yerkes?
YerkesObservatory.org. You are welcome. There's a donate option through PayPal on there. And it often works, I'm told.
Okay. So even if it's a small donation, every little bit counts.
Literally of that $13.5 million, many of those are, $100, $50 donations. It's amazing how many people have stepped up. So
I think it's awesome. And you guys are doing a wonderful job. So thanks very much, Dennis.
Well, thanks for the invite, and have a nice night, everybody.
Take care.
All right. Bye-bye.
Okay. So coming up next is Karim Jaffer. Karim is, he's a professor of astronomy. He is an outreach leader with the Royal Astronomical Society of Canada and Montreal Center. But before we go to him, I also want to just make a little segment about the Alliance of Historic Observatories, of which Yerkes Observatory is one of. They are, I guess they could be considered one of the poster childs of this organization. And this organization is now growing as well. So if you go to historicobservatories.org, you can learn more about this. And I'll just go ahead and put that down in chat. But it is, a subset right now of historic observatories from around the world, and I think you'll find it interesting. Karim, how's your day been? You've been busy with your students, and you're a busy man as well.
Yeah, no, today was test day. They had their first test on solar system, on a little bit of the history of astronomy. So today fits right in there. We're about to start the second unit on Thursday, and we're going to be diving into the sun, stars, and eventually getting to the expanding universe. So I'm doing a little bit of the history side and a little bit of the expanding universe side for us tonight.
Yeah. So now you know where I get all my themes from. I get them from Karim. So
I'm convinced you've got my office bugged or something. It seems to always overlap. Oh,
yeah, so
fantastic.
it's great. It's great. Okay. So here we go.
So thanks, Scott. So yeah, hey everyone, good evening. And we are talking tonight about the expanding universe. But as I always do, I want to do a little bit of a check-in first. Our university lowbrows in Michigan, we just had our newsletter come out, and I was glad to see my daughter actually put a newsletter article in about the cosmic generation, which I'm going to talk about shortly, as David mentioned earlier. A lot of you know me from the RASC Montreal Center and our public events. Our next public event is going to be during Earth Hour on, right leading up to Earth Hour on March 26th. So you'll hear more about that in the coming weeks. But some of you also know me from Astro Radio. And we were very privileged yesterday in Astro Radio to have with us a special guest, David Eicher. He came on our Reach Out and Touch Space panel show yesterday, and we chatted about StarMist. We chatted about David's work at Astronomy Magazine for the last 40 years, about their 50th anniversary coming up. Also a little bit about David's start. Now, I don't know how many of you are aware of this, but David got his start publishing his own magazine on Deep Sky, and he just saw a void, saw an interest area that a lot of youth had, and he decided to just go ahead and do something about it. And that's a perfect segue to our cosmic generation, because the cosmic generation is something that David and I chatted about a long time ago. Dina, the president at Denver Astronomical Society, was trying to start something up with the youth members there. And what they were trying to do was they were trying to come up with a way to bring together youth from not just across the nation, but potentially across the world. And we've now arrived at a global astronomical organization by youth for youth. And a couple of weeks ago, you saw the outcome of their first workshop, which was some wonderful alien drawings and some wonderful imagination and learning about extremophiles. Their next workshop is this Sunday. It's at 3 p.m. Mountain Daylight Time. Keep that in mind, because the clocks do move this weekend for a lot of us. And their talk this weekend is just going to be fantastic. They're going to have a workshop on how big is the universe really. They're going to talk about size and scale. And their goal is, and this is a goal that I don't even know if I can do, but they want to try to come up with a way to share both the immensity of the universe and how small we are in comparison, and yet share how important our presence is in the universe. And that's kind of pretty fantastic to hear about. So my daughter Tara is one of the exec, as well as Bella Grant, Nathan Hellner-Messelman, and several others, Ty, Michael. We've had some incredible work being done as well in Brazil. And Nicolina has been one of the outspoken members of the Cosmic Generation. So for kids up to age 17, we invite you to please join in at this workshop and take part, get a feel for what it's like. As Nathan and Bella both have been saying, you know, it's about being able to share your passion for the night sky with other nerds, other geeks, other people who share the same language, share the same interests, and want to talk together. But I don't want to be the one to put words in their mouth. They're fantastic together. Unfortunately, Nathan couldn't come tonight, but you'll probably see him, one of the future GSPs, talking a little bit more about the cosmic generation. I want to mention, and an invitation to anybody who's interested, is we have our next Citizen Science series coming up on Wednesday, March 16th at the RASC Montreal Center. It starts at 8 o'clock Eastern Daylight Time. And we're going to have a couple of really interesting segments for our Citizen Science series. We do have a double star certificate presentation. As some of you attended our last Citizen Science workshop, we were talking a lot about double stars, and a couple of our members are really pursuing our local certificate as well as the national certificate. And we're going to talk a little bit more about some of the national RASC programs next week. But for our Citizen Science series, Francois, who's our guest tonight, he's going to be talking about a star tracker that he built for his own wide field astrophotography. And he's going to go in depth into the build and kind of go into a little bit of the nitty gritty. So any of you who are interested in that, I think you'll really enjoy the Citizen Science series. And then I have a special treat. A couple of my students have put together some retrospectives on their project experience with my astronomy course at John Abbott. And they're going to share a little bit of what they did in Citizen Science and what sort of skills and what stuck with them now that they're at university and pursuing, hopefully, their career path over the coming years. And so we invite you to join us for the Citizen Science series. The other thing I want to mention is, as Scott has said before, I do kind of try to stay active in the chat during our global star parties. And, I love hearing about, Norm and Chris and Harold and Beatrice and Lisa Ann and others setting up their scopes while we're doing the GSP. And then maybe later at night, they'll share some of their images. And so just as I was getting on tonight, one of our RASC Montreal members who's presented here at the GSPs before, Quatran, Deep Sky from Downtown, he posted this little picture to me, his nice little reflector set up, a tabletop on the back of his rented car, and his camera set up to do some wonderful astrophotography right there in the mounds of snow that we have here in Montreal, because, hey, the sky is showing a little bit of clearing, and it's not negative double digits, it's single digits. So he figured, why not get out there and spend a night under the stars? So when I saw Scott's choice for tonight's topic, I was remembering the last time we talked about the expanding universe. And, we talked a little bit about the science and a little bit about the redshift. And I saw that there's a speaker talking a little bit later about the redshift universe. I wanted to take a little bit of a different tangent because, I'm apt to do that. When I started teaching astronomy, one of the big things that we talk about with the expanding universe is, of course, Hubble's data. And we talk about where that data came from and how it showed sort of a relationship between this idea that objects further away from us, galaxies further away, quasars further away, now that we can take measurements of quasars as well, they're receding away from us at faster and faster speeds the further away they are. And this holds with this idea of a Big Bang, of an expanding universe. And the original Hubble's data, for the scientist in me, there's a lot of scatter there. There is a definite type of a relationship, but there's a lot of scatter, and I need to see error bars to know exactly how good this is. But this was the original set of data. And when you look in the astronomy textbooks about the expanding universe, you see that when Humason helped Hubble to get even more data, and they expanded from the original data work that Slipher had done, they were able to really expand to extremely fast recession velocity. And they came up with a Hubble factor, this idea of the expansion rate of the universe, which was much more linear. And even with your scatter was much closer to this linear relationship that said that the further away a galaxy is, the faster it's receding from us. The problem was that when you did the math and you looked at the slopes, you came out with an age of the universe less than the age of the Earth. And that age of the Earth was taken from carbon dating of rocks here on Earth. And so we kind of had a fairly definite idea that there was something wrong here. Now, a lot of this work was done at Mount Wilson Observatory. And I'm going to be talking to you a little bit about the story of Mount Wilson Observatory. And I'm going to be talking to you a little bit about where this data came from. And when we talked about this back in the fall with the expanding universe, we mentioned the fact that when he got to work at Mount Wilson and got to look at stars and image fainter and fainter stars, he realized that there's actually a second population of stars. And that second population of stars is older stars. They're stars that were around from when our galaxy was first being formed. And there's even now a hypothetical third population of stars that were around just when the universe was starting to be formed that would have even less metallicity than the population 2 stars did. But when you account for this difference in the types of stars that were actually being analyzed by Hubble and Humason, all of a sudden you get a much smoother curve with an expansion rate that gives us an age of the universe that's something a little bit closer to a consistent age with what we thought we'd be getting. And then, of course, more recently, we have analysis that shows that the expansion is accelerating and that the expansion rate actually was much slower in the earlier times when our universe was first forming out. And so there's a definite missing element in the theory for the expanding universe, which we call dark energy. And dark energy seems to give us this idea of why the expansion is accelerating. Now, I could spend hours talking about all of that. But what I want to focus on is something a little bit different. When we go and look at Mount Wilson and we look at the story of the expanding universe, and we look at who they credit for the heroes who really got all of the research started. There's George Ellery Hale, who after Yerkes set up the 60-inch reflector using a 60-inch mirror that he had, and then used that to leverage to get money and resources to actually get a 100-inch reflector, which was enabled them to do all that amazing work with the Hooker telescope. There's Walter Adams, who did a lot of the amazing work to actually set up the science research groups that worked under the auspices of Mount Wilson. And one of those was Hubble's. And Hubble's work is what's credited with understanding the expansion of the universe. When we look at these pictures, even when the dignitaries like Einstein were visiting at Mount Wilson and they were gathered together in the library, there's a gentleman there off to the side who I mentioned earlier, Humason. Milton Humason is there in the pictures. He's mentioned with Hubble, but I find often that either his story goes unrecognized or misrecognized. So I wanted to spend a little bit of time tonight telling you a bit about Milton Humason. Now, where this comes from is when I started teaching the astronomy course, one of the things that I'm known for from my family is, we have books. You wouldn't believe how many books we have in the house. And I still always go into used bookstores, and I still always go into new bookstores, and I'm looking around and I'm always trying to find a book that could capture the excitement. And sometimes I get a book, I'll read a little bit of it, I'll store it away, and I know it's there for when I want that information again. But I came across this book very early on when I started teaching astronomy, and it's called How Far Is Up? It's by John and Mary Gribben. Now, John Gribben was a PhD student of Fred Hoyle in the UK. He and his wife, Mary, they have put together some incredible biographies of scientists. But this particular book isn't as much a biography of one scientist as it is a contextualization of how one scientist led to an appreciation for how anybody really has a passion for the night sky, they have a way to contribute. And that's what I want to talk to you about Humason for, because not all of us on this call, not all of us in the audience are trained scientists. And I've talked to you before about the importance of citizen science. And in my mind, Milton Humason is one of the first citizen scientists, just in terms of the way in which he applied his work ethic and his attention to detail to allow us to have an understanding of the expanding universe. So when I look up pictures of Milton Humason, one of the ones that I came up with is this one at the 100-inch Hooker telescope. But some of you will recognize this picture because this picture often is shown with a caption saying, Edwin Hubble at work at the eyepiece of the 100-inch Hooker telescope. And I tried to find the provenance of this picture. I checked the Houston University library. I checked the actual Mount Wilson Astronomical Observatory and their historical index. And I was trying to figure out if there was any actual authentication. And most of the people who would say that this isn't Humason and that this is Hubble would point out the fact that Humason always had glasses on. But then they have this picture of Humason and Hubble at work at the telescope trying to install the spectrograph at the early stages of the work that they did on the expanding universe. And you can see neither of them are wearing glasses. And so I truly believe this is a picture of Humason at work simply because Humason was the one who did most of the observing. Hubble did most of the analysis and the theoretical work, but the observing of the spectra and the observing specifically of following night after night after night the target to develop enough photons hitting that photographic plate to know that you have enough photons to make an accurate estimate of what it is you're seeing, that fell to Humason. So how did it fall to Humason? How did he come up with this? Well, when he was in high school, he was one of those students who didn't really excel. And the reason he didn't excel is because he wasn't really interested in the hows, in the understanding the background or the knowledge base. He wanted to do, he wanted to act, he wanted to be a hands-on person. And so he convinced his parents to let him spend a summer working at Mount Wilson Hotel. And he ended up never going back to school because while he was working at the hotel, the Mount Wilson Observatory already had the 60-inch telescope up there, but they were starting to build more and more into the observatory. They'd widened a track up the mountain to start to actually set up the larger base of what the observatory would become down the road. And so he managed to get a job as a mule driver just to take supplies up to the actual hotel, or to the observatory, sorry, from the hotel area, which was base camp, and just help get things there. And then he saw the way in which the observatory itself was being built, and he befriended a lot of the people there. One of the people he befriended was an engineer, and the engineer's daughter, Helen, became Milton's wife. And so once you have a wife, once you have a family, you have to become a responsible person. So he went and he invested in a citrus farm, and he, let go of his joy of being up on the mountain. But he always remembered that he loved being under the stars. He loved being up on the mountain, and he loved being part of that new venture that was up there. So around mid-1917, his father-in-law, who was one of the engineers, said that there's a job up there if he wants it. And so he decided, you know what? I get free lodging, I get meals while I'm working. Even though the pay is awful, I'm going for it. And so they sold their citrus farm, they moved up there, and he took a job as a night janitor. Now, in November 1917, as a night janitor, when the World War was just hitting and there were really a lack of people available to do the work at the observatory, he was given the responsibility to start actually doing a little bit of the observing, of actually moving the plates around and moving the telescope to keep it on a target. Because even though the 60-inch telescope had a tracking mechanism, that tracking mechanism needed to be observed at all times and adjusted. And he proved to have an incredible eye at keeping the target as close to the center of the photographic film. And sometimes one day of observation is not enough for a very faint object. So the next day you have to load the plate back in the right orientation to catch the object and then continue following it through. And Milton was the one you would go to when you had a job like that. Harlow Shapley was one of the ones who saw Milton's work. And so he suggested that Milton be added to the scientific staff. And George Ellery Hale decided to take a flyer on him and say, you know what, he has no background. He didn't even finish his high school education, but he has a trained eye for an astronomical observer. And he has a care when it comes to working with these photographic plates. And so he added him as a junior scientist to the staff, much to the chagrin of a lot of the other scientists there. Now, Shapley loved the work that Humason did, and he gave Humason a lot of responsibilities for his own research work. But Shapley also had a very particular view of what it was he was seeing in the night sky. And so about a year and a half later, Humason was going through some pictures of the Andromeda Nebula, which at the time they thought was just a nebula of gas within our Milky Way. And he realized that there was an object there that seemed to be a star that was becoming brighter and dimmer and brighter and dimmer. And it was a Cepheid variable star. And so he went back through multiple plates, and in each of the plates, he characterized exactly where the star was. He drew lines on with black mark or with black chalk, basically. And he drew these lines, and he took all of these plates to Shapley, and he said, look, there's an actual Cepheid variable star here. And Shapley said, no, this is a cloud of gas within our Milky Way. There's no possibility of having a Cepheid variable star in a cloud of gas. You're not seeing what you think you're seeing, and proceeded to wipe away the work that Humason had done and the observation that he had made. Now, Humason, he had no scientific background. Shapley was the one who brought him onto the staff. So he decided to let it go, and that actually prevented Shapley from being the first one to recognize that the Andromeda galaxy was actually over 1 million light years away and was not part of the Milky Way. But had he looked carefully at the observation that Humason had made, he likely would have seen that exact result. Now, what Humason is known for is his work with Hubble, and his work with Hubble came in a very interesting way. Now, a lot of us know that what Hubble was doing was he was looking at these Cepheid variable stars in other galaxies and using them to determine, based on the light that came to us and the periodicity, so we know what light should have come to us, how far away those different galaxies are. Now, he didn't take into account dust, which can cause the light to dim. He didn't take into account the population of stars, so his Cepheid variable calculations were wrong, but the idea was right. And when Vesto Slipher first published this idea that for 25 different galaxies that were fairly bright that he could see with a 24-inch telescope that he had access to, for those galaxies, the vast majority of them had redshifts moving away, and the further ones seemed to have a larger shift, which means they had a larger recession velocity. When Hubble came across this, he knew that this was something that their 100-inch telescope at Mount Wilson could shed immense light on. But he also knew that he wasn't the one to take those accurate measurements. He needed a staff observational astronomer to do it. So he approached Humason and he said, can you do this? Will you do this? And Humason originally said no. And the reason he said no is something that he talks about in his oral interview, which is on the American Institute of Physics website. This was in around 1965. He's doing a retrospective of his work with Hubble. And he talks about the fact that when Hubble approached him with this idea, he said no, because he knew that the spectrograph that they had at Mount Wilson would require days upon days upon days of observation of one target just to get one spectra. And that one spectrum would be so faint and so difficult to do. And he didn't really care about it. He understood that there was a significance here, there was a puzzle here, but it wasn't a puzzle he cared about at that time. So he said no originally, and then Hubble kind of asked him, please just at least do one. Let's see if this can be done. And their PRISM spectrograph was a really interesting one because it cut out ultraviolet wavelengths. So you couldn't do the normal hydrogen spectrum that you would be looking for. So what he ended up doing was calcium H and K lines. And the calcium lines that he did allowed him to look at these recessional velocities of redshifts of galaxies for faint galaxies that Slipher had no chance of seeing in his 24-inch telescope. So he did a couple and he saw what Slipher had seen. So he saw that it could be done with the 100-inch, and it was much easier to do with these bright ones. And then Hale had caught the bug. And so Hale called Humason in and said, look, if you're willing to do this with Hubble, I will invest in a better spectrograph. And so that better spectrograph will allow us to do all of these things in one night rather than over many nights. And Humason was sold. He said, okay, let's do this. Of course, once you have a better spectrograph, you look at fainter targets, which again means multiple nights. So he spent all of his time looking up through that eyepiece, making sure that the photographic plate was perfectly centered so that you could get incredibly accurate spectra. And when he did so, he was able to help Hubble to prove that this relationship of receding galaxy velocities with distance actually was a constant relationship you could see in the night sky. The universe truly was expanding. And Humason talks about the fact that there were problems and there were puzzles that he didn't have a chance to work on because of the limitations, even of the 100-inch telescope. But I love this quote: nothing in astronomy is a disappointment. You make an observation to try and find out what it's going to do. You think it's going to do something, but all of the interesting problems come from the things that didn't turn out the way you thought they might. Now, I want to end with one of the quotes when they asked him what he's doing with his retirement and whether he still wants to go back and be an astronomer and work at it. And this is where you really get the understanding that the puzzle was interesting to him, but the theoretical side was not what drove him. He enjoyed his time, but he was done. And he said that my son wanted to buy me a telescope for a present. And I said, my God, Bill, I've looked at an eyepiece all my life. I don't want to look at any more eyepieces. No, no, no. I want to fish. And that's what I've been doing ever since I'm up here. Steelhead and salmon, that's my business now. Talking with these old timers around here. Now, in a lot of the books that I was looking at for my students, Humason is talked about as this example of, you don't need a fancy degree to do really good. This no nonsense blue collar Humason showed up all those amazing theoreticians by doing what none of them could. That wasn't Humason at all. Humason was an incredibly precise, incredibly technical observationalist. And that's what he wanted to be. That's what he was. And with that, he contributed to our understanding of the universe to a point where even now we go back to his original data and we keep getting more and more results out of it. But that's a story for another time. So that's what I wanted to share with you today. Scott, are there any questions before I move on to our guest?
People are just, I think you're kind of inspiring people to, what it would be like to look through a large aperture telescope. And so there was some conversation about, if you could see color visually through these large telescopes. And I've looked visually through the 60-inch and the 100-inch telescope. And actually, I've also looked visually through the 200-inch at Palomar at the Coude focus. And amazingly, those telescopes have such huge focal length that big objects like the Orion Nebula, for example, I mean, you could see the kind of the aqua blue green color, but I've seen kind of more amazingly like reddish, red tinges and stuff in the Orion Nebula with a smaller telescope, because you're at much lower power. And that's
Exactly.
kind of what you need. But I will tell you that compact objects like planetary nebula, wow, they're like in Technicolor.
Oh,
okay,
wow.
they're in Technicolor through 60-inch or 100-inch telescopes.
And I will
So
point
it's-
out, Scott, for his birthday, actually had set up donations to Mount Wilson because it was still under renovations after that big forest fire last year.
Yeah.
And that was incredibly moving. I shared that with my students last fall because that is a historical place. I mean, the science still being done there is incredible.
Right. That's right. And the legacy of the history. I mean, it was certainly when you think about the formation of astrophysics itself, it gets its birth at Yerkes Observatory. You have spectrographs being used on that great refractor. But, George Ellery Hale wasn't satisfied. Actually, he was only there for a short time before he started working on the 60 and then the 100-inch. And, I think that somehow George Ellery Hale had sensed how short life is and how much he wanted to accomplish, in that time frame. So he quickly got to California. The people at Yerkes felt a little, I guess, cheated that he had left. But there were still, amazing people that went through Yerkes. Carl Sagan was there, and
Yes.
a long list. Of course, they moved through Mount Wilson, making incredible observations and understanding the expansion of the universe there. And then we get to the 200-inch, which has its own story. So
Yes. And I even was reading about Humison's work at the 200-inch, and I was just like, no, that's too far. I'm going to leave that for another night. But I think David wanted to add something as well.
I didn't even know he was at the 200-inch. So
He spent a little bit of time there and was saying that was actually what he was referring to when he said, there is no disappointment in astronomy, because he ended up leaving the profession around that time. So he went there, he saw what could be done, but decided not to have himself be the one to do it.
Wow.
One comment that I wanted to make, Karim, is that I really did enjoy your presentation. The historical context was just beautiful.
Thanks, David.
In addition to all of the books you mentioned, I'm going to add one more. In the original Cosmos, the one that Carl Sagan did, he devotes a good portion of episode 3, I think, to the story of Milton Humason.
Yes.
Of course, we're all familiar with Comet Humason. It was a comet in, I think, around 1960, very bright one. And he really, really took off. And his story is really enlightening, and it's very inspiring. Thank you, Karim.
Oh, my pleasure. I was frustrated when I would read in some of the introductory astronomy textbooks, and it would be a footnote that Hubble had an assistant named Milton Humason. And I was just like, no.
So important to the discovery of the expansion of the universe. So
Exactly. So I also have a guest with us tonight.
Yep. Let's bring him on.
I have been really enjoying over the last few years. We have a couple of astronomical groups on Facebook here in Quebec and the Montreal area. And every now and then I see the name Francois Quesnel, and I see these wonderful pictures. And, I've shared a couple with my class. I've messaged him to ask permission. And then we started chatting, and it turns out he went to University of Guelph around the same time I did. And, he's been doing this amazing work in astronomy and astrophotography as a hobby on the side. And so I thought it would be great for him to share a little bit of what he does in astronomy and astrophotography, his approach, his workflow, a little bit of what he does. And then those of you who are more interested in some of the stuff he shows are welcome to join us next Wednesday at our Citizen Science episode and ask him more questions directly. As some of you know who've joined our Rask Montreal Clubhouse, we don't go on formality. We all just kind of chat whenever we want, and David will be there. So Francois, we're looking forward to your presentation.
Okay, well, thank you very much, Karim and Scott, for having me over tonight. It's a great honor, a great privilege to address all of you like that. Just a note about me: I'm an agronomist by day and amateur astronomer by night. So I have no background in astronomy, no training in photography. I just have a day job and I enjoy the night sky. And I've been enjoying the night sky for the past 40 years now, actually. Started out with just a star finder and binoculars, and then grounded my own mirrors for telescope, first a 4-inch and then an 8-inch. And then going into clubs and becoming president of my astronomy club, organizing summer camps for young astronomers. So I've always been involved in this, and slowly moving towards, as I got older, towards photography. And so that's what I'm going to be talking about tonight. What you see behind me is my equipment that I use usually on a night out. I have 2 Pentax bodies. This is an old K5, 12-year-old, and still very good, with a little GPS on top I'm going to be discussing. And this is a DIY tracker that I'm going to be presenting at the Royal Astronomy Society next week. And with a newer Pentax K70. The lenses I use are, this one is a Samyang 16mm f2, so very fast lens, and this one is a Sigma 35mm f1.4, very fast. And so I'll just share my screen to show what I do with those. Okay, so what I'm going to be talking about is Nightscapes the easy way, because really what I like about astronomy, what got me into astronomy 40 years ago is just stargazing. And what keeps me in astronomy is still stargazing. So the photography part has to be simple, it has to be easy, doesn't need to cost an arm or leg. So what really I enjoy mostly is just stargazing. On a night out, this is my favorite activity. Just enjoying the night sky in my chair, and I think ever since I began watching the sky 40 years ago, watching the sky always comes with where you are, the landscape you're in. And I've always wanted to get a souvenir from those nights. And so that's what got me into landscape photography in the first time. But in the film days, it wasn't easy. But I was very impressed with, pretty sure many of you have a copy of the Burnham Celestial Handbooks. If you look through the pages for Orion, Taurus here, there's a lot of those pictures where they're nightscapes, right? You can see in this one, Pleiades are a lot of details. You can see the California nebula. So it's definitely a very long exposure that's been taken to reveal all those details. But the foreground is very sharp. So how did they do that? I figured, well, he must have had the picture of the night sky, and then he put another in the dark room. He must have put another negative with the foreground very, very contrasty, so that you could burn all the parts of the image that are not the sky. Must have been something like that, very complicated. I tried my hand at it. It was very long, was very painful, and I got something like this that, you know, I didn't really pursue. It was just too much work. And the only keeper frame I have from film photography is Comet Hale-Bopp. And I realized this picture was taken almost exactly 25 years ago. It was in March '97. So really, the in the film days, I never really was able to do what I wanted. But in the early 2000s, I bought the Pentax cameras, and in 2011, Pentax invented the AstroTracer. It's that little GPS unit that I put on top of my camera. It's a GPS, and it's also a compass. And so the camera knows where it is on Earth, what time it is, with the accelerometers in the camera. The camera knows where it's pointing in the sky. So there's an engineer at Pentax that said, well, with all that information, why don't we program the sensor in the camera to move so that the stars stay sharp within the frame? And so that's a little gadget that I found was very, very practical. If you've done photography on a fixed tripod, you've probably heard of the 500 rule, which is, if you want to know how long you can expose with a lens, you divide the focal length of the lens by 500 by the focal length of the lens, and it gives you the approximate exposure time you can get. So if you have a 50 millimeter lens, 500 divided by 50 gives you about 10 seconds of exposure before the stars will start trailing and ruin your photo. But with the Pentax AstroTracer, the 500 rules become the 5,000 rule. With a 50 millimeter lens, you can expose for 100 seconds. So that's significant. And about the tracer, I have set up a website, tracerphoto.com, because now with that technology, basically anyone that's interested into photography can do astrophotography. And on the Pentax forums, I get a lot of questions about the tracer. And rather than answering everyone individually, I finally decided to put all the information in that site. So if you want to have a look about the tracer, that's where you go. And the tracer at work, well, this is Comet Neowise in the summer of 2020. And you can see, compared to the Hale-Bopp picture, it's
It's beautiful.
Thanks. It's a lot sharper. It was a lot easier to get also. This is only a 10 or 12 second exposure with a 50 millimeter lens. And so the tracer was on, and so the stars appear a little sharper than if it had been just a fixed tripod photography. This was the morning of the 6th. I was very excited when I took this picture, because we didn't know what the comet would look like. It had just come around the sun, and it was said it was going to be a great comet, but I hadn't seen pictures of it yet. So to be able to catch it with a 50 millimeter lens like that, I was really, really amazed. A little later on July 18th night, I went with the 50 millimeter lens and took this picture. So this is a 60-second picture with the AstroTracer, and the stars don't show trailing. Of course, when you do a landscape like that, the foreground will be blurred with the AstroTracer. So what you need to do is you take a picture of the stars with the tracer, and then you turn off the tracer and you do another 60 seconds for the foreground to be sharp. And then I don't have anything very expensive as far as software goes. I just use Raw Therapy, which is free, and I use Photoshop Elements, which is less than $100. So I don't over process. I don't have a lot of processing tools with my software, but it's easy enough to just blend the two images and make it look with sharp foreground and sharp stars, no trails. Now this lens, I realized right then that the winter before that, we were talking about sub-zero temperatures, and I discovered that the lens produced halos around the stars that didn't used to produce. I've been using it at minus 32 degrees, and it kind of destroyed its better qualities. This is another shot taken the same night with a very cheap lens. So really, astrophotography, night sky astrophotography doesn't have to be very expensive. I didn't bring my Sigma lens, so I use here, it's a Pentax lens. It's a $100 lens, brand new lens for $100, and it got the color rendition is a lot better with these newer lenses than the old 50mm lens that comes from the 1980s. And so it was here another 60-second exposure for the stars and a 60-second exposure for the foreground. So the Astro Tracer really makes it easy to shoot the stars. This picture, Karim showed this one to you a few weeks ago, and this is what I like about the astrophotography. It's how you can show the place of Earth in the universe, basically, right? The night sky when you're stargazing is the only time where you get a sense of the place of the Earth within the universe, and having the Milky Way is of course our own galaxy, is of course something that really appeals to me in an astronomy picture. Of course, here I wanted also to show the entire winter hexagon from Capella to the north, and to Sirius near the horizon. So these pictures all done the same with the blending method of a sharp foreground without tracing and sharp stars with tracing. And here, to get the entire 90-degree view, I had to do stitching of the pictures, and so it's all done with very, very simple tools. Nothing complicated about that. Something I really like sometimes in nightscapes are clouds. They really, it's almost, when you look at this picture, it's almost 3D. You can see the ceiling, the cloud ceiling, and then above it, you see the universe. I mean, when you look at the clouds and the lake and the trees, there's Earth, and right above that, the big sky is right there above the ceiling. And so in astronomy, in astrophotography, usually clouds, you don't want any clouds in your pictures, but in nightscapes, sometimes they do add a little effect. Another thing I like to do with my pictures here, I think it shows, you've got this huge bulge of the Milky Way here. You got the foreground is a hayfield, and you've got this tiny farmstead, really, really small in the horizon here, and so it kind of shows the relative sizes of where we fit in the universe. And this one, churches are very great to shoot in the night, because it really, those bell towers, why are they so high up, so arrow-like, if not to remind us of our link to the sky, really, so it's only natural, I think, that churches.
How did you like the headstones there?
Yeah, around that's in eastern Ontario. All the churches in the countryside, they're all surrounded by the cemetery, right? And I was in a very light polluted area, and there was street lights in front of the church, so it was really difficult to deal with all that light. But yeah, it really, the church, the bell tower, arrow light like that, it really makes a link between the Earth and the sky, and with the Milky Way in the back. It's it's really gives a sense of place where we are in the universe. When I get tired of the light pollution around Montreal, I drive about 5 hours to the Charlevoix region. That's where I organized back in the days summer camps for kids, for showing them the night sky, and you can see it's still just a 60-second exposure, but look how the Milky Way shows up very, very easily. I didn't process more longer or used anything different. It's just so colorful when you're in the dark sky like that. This is a picture. Spruce trees, I think, like bell towers, because they're so straight up and they point all at the zenith. They naturally make a very nice foreground for astronomy pictures. This was done with the Astro Tracer, and I went back the year after that. This is with my DIY tracker, and I was trying to do the same image. Instead, I did a 2-minute exposure, so the Milky Way is a little brighter, and I use also a filter. You can buy these filters. They're by Tiffin. They're called Double Fog 3, and they do the fog effect on the brightest stars. And so I took a 2-minute without filter and a 2-minute with a filter, and I blended them in Photoshop Element, and it makes like the Cygnus constellation stand out more. The dolphin here stands out more if you compare with no filter at all. So these are little things you can do to add to the picture. One thing I like about the tracer, it's so small. This was about a 20-minute hike down the mountain to the bay, and so couldn't get very heavy gear down there, and just for tracer being so small, it fits everywhere. And so this is a picture of Mars in 2018. So this is another thing I like to shoot. It's out to see when I see the constellations and the planets with a landscape. Here the moon was rising. It was about the last quarter of the moon, and so it shed some light on the spruce trees there, and it wasn't so bright that it completely washed out the sky. And so another very nice moment to shoot is when you get these conjunctions, and you really get a sense again of the Earth in space when you witness something like this. We've got the Earth with the little shed, and the moon with the thin crescent, and Venus and Mercury. And usually the planets will line up along the ecliptics, which must be somewhere around there, but here they nicely were perpendicular, so it was easier to make this picture with the close foreground, and as we go up, we move further and further out into space. So this is what I wanted to share with you. If you have questions, I'm here.
Well, I think in general, Francois, people are blown away. So,
Francois, that last image you shot, what was your exposure time and your settings on that?
That was a 70 millimeter lens, probably around f4, and 1 or 2 seconds, with ISO probably around 200, 400, something like that. Yeah, when you have a good dynamic, if you want a good dynamic range, you keep the ISO as low as possible.
Beautiful picture, incredible.
Thanks.
Yeah, Francois, this is Adrian. I believe you do your nightscapes for the exact same reason that I do my nightscapes, as a way of showing Earth as a part of the universe. Your images are well done and have a lot of soul in them. Your views really do come out in the images that you produce. And I really like the idea of you don't do much processing, you're showing what's there. And when you do that, you take people to those places as if they're sitting there watching with you the night sky. It may enhance a little bit because it comes on that sensor, but there's no, and for some that can do the over processed cartoonish look, it's I think there's a time and place for that. I also prefer sort of the very simple but very beautiful natural look. So thank you for sharing your images with us.
Well, thanks for your kind words. Very, very much appreciated.
Right.
I'm loving some of those landscapes you got nearby Montreal. I'm kind of curious now. We're gonna have to touch base on some of the locations you've got, because so you do a lot of
the
Eastern
rest
Ontario
is
as well.
it's close to, I think, Alexandria, and so you're right in that part.
Yeah, but I mean, when you talk about the Charlevoix region, when you go east past Quebec City, the skies just go dark. It's incredible.
Yeah. Most of the pictures I've shown were shot from bottle 4 or 5 skies, but the Charlevoix is a 2 or a 3 at some places. Yeah.
I'm curious that Eastern Ontario church one that you took, where you said there was a lot of street lights and a lot of light pollution, but you got incredible detail on the sky above it. Did you use the same settings, or did you?
Yeah.
Yeah. Wow.
Yeah.
Okay.
That's a great camera.
Yeah.
But I will also point out that the compositions that you presented were amazing. So that such carefully crafted images don't come by accident. So sometimes you might get lucky, but when you see an amazing image after an amazing image, then you know that the photographer really has a gift. It's great.
Well, thank you very much. And yeah, you're right. Those pictures, as an agronomist, I have the advantage of roaming the countryside in the day, so I can see a lot of good, interesting places to photography at night. And that barn in the snow with the winter hexagon, I had done. I knew I kind of knew what it would look like with the camera, but I tried to do it about a month earlier, and when I went, there was a big fifth wheel trailer parked in front of it, so it kind of ruined the picture. So I went back, and I was afraid that there would be too much snow. I said, "Oh no, my window for getting there is busted." But usually that side of Montreal gets a lot more snow than Montreal. But when I went, luckily there was very little snow on the ground, and I was able to get there. So yeah, you have to try, and sometimes it doesn't work, and you can come back and try again.
Right. Well, I know that our audience wants to see you back on Global Star Party again. So thank you very much. Thanks for participating. That's great.
Yeah,
well,
Scott, I had one more quick question for him. Francois, have you ever gotten any, I'll call them Easter eggs, any surprises with images that you've taken where you didn't expect much, but when you looked at it, you realized you'd gotten something a lot better than you had even hoped?
Yeah, so yeah, I see what you mean. So sometimes I get the pictures and I think, oh, this is gonna be the greatest picture. This is really I've nailed it, and turns out to be very ordinary. And the order, something I just shot as an afterthought or something, turns out to be the shot. Like the Mars shot in the bay, I was going down to shoot the Milky Way, and Milky Way turned out to be very ordinary. But that part of the picture, it's a heavily cropped image actually. That part of the picture, I said, wow, okay, look at that Mars. Look at how it shines in the water. And so that's an Easter egg for you.
Excellent.
Yeah,
Okay.
go ahead.
All right. Well, thank you very much. And we do look forward to having you on again, Francois. Thank you so much.
Thanks.
Up next is Daniel Higgins. Daniel is a very enthusiastic outreach ambassador, I'll call him. He is responsible for AstroWorld and AstroWorld TV and AstroWorld Web. And so I'm going to ask him to come on with us. And I'll hang out with you because I know that sometimes, and I'm also, he said, Scott, I need a wingman. Now I am also someone that needs a wingman. You guys have seen me come on by myself and I'm a little awkward and stuff, but if I have someone with me, I just feel better. So, so Daniel, tell us a little bit about yourself, because there's going to be some people that don't know you. Okay. But I know that your programs are very popular and getting more popular all the time. So it's great for you to spend some time with us. What got you interested in astronomy to begin with? You're so involved in it now. So, and your audio is not coming across.
How's that? There you go.
There we go.
There
That
you go.
works.
Sorry about that.
That works. I do that too sometimes.
For all the people out there that watch AstroWorld, that is the glitch of the night. So for those of you that watch me, we always have that. But yeah, so
Yeah, I'm unable to. Daniel, we're unable to.
I hear him fine.
let me check on my.
It's still not quite coming through.
I'm not coming through.
I can hear you.
I can.
Okay. All right. All right. Good. It wasn't me. Yes. Awesome. With AstroWorld, yeah. Well, I guess what first got me into astronomy, I guess I was about 7 years old, I guess, and my uncle had, I guess it was like a straight through 60 millimeter scope with no diagonal, nothing. We were in Hicksville. So Hicksville, Long Island, just so you know a little bit about me and where I'm from Long Island. So I'm in the light pollution capital of the world for the better. If you understand, I know Tarek, who's out in the UAE, me and him talk all the time regarding the issues with light pollution, and it was just nightmare. So of course, what's the first thing I see out of my uncle's telescope is Saturn. So the first thing I see was Saturn, and since then, really, I was hooked. And that was awesome. It was this little dinky thing. I thought I was reading, I forget who exactly wrote the text on it. It said Saturn has ears, and that's what it looked like. It just looked like this little bubble with a little thing. It looked like a little Mickey Mouse hat, and that's what really got me hooked. So when I finally got a job and was able to purchase my own scope, I bought an 8-inch. What was it? It was a Ultima 8. It was an Ultima 8. That was my first one.
That was your first telescope?
Yep.
Wow.
Well, my first one that I purchased myself.
Okay.
I think my first was like a Bausch and Lomb or a Tasco or something.
Okay.
It's a
Like a small
400 pound. Yeah, exactly.
400 power, 4,000 power telescope.
Yeah, exactly. Oh, yeah. Look at these pictures. That's exactly what you're not gonna see. And and that's how I got hooked. And I became a visual astronomer first, up to purchasing an 18-inch Obsession Classic, which I still have. And I love doing it. One of these days I'll finish my Herschel 400, which I'm attempting to do, but I have a feeling that it's going to be a while. Got a lot of Cherry Springs trips. And then basically, started astrophotography, and I loved getting that instant gratification of the picture and all that. So I started doing that, and I started doing it with the Minolta Maxim. I started doing film, and like one of your guests before said that I really couldn't get what I wanted with film, and neither could I. So you're not alone. And I was able, once the digital age started coming and we were able to get better and better technology, all of a sudden my pictures started getting better as well. And I found that I didn't want all the other people that come after me to step in the same landmines that I did. And so that's what started AstroWorld and AstroWorld TV and all that. So now we do I'm sorry, I thought there was a question. I'm sorry.
Oh, go ahead.
No, we do 2 live shows a week, Wednesday nights at 9 p.m. and Friday nights at 8 p.m. Eastern time. And we have nine current people now that come in and out as hosts. And we got people from New Zealand. We got people from all different types, from pure beginner to a gentleman that just purchased his first plane wave. So I mean, so we have all sides of the spectrum, from the ASI Air users to the Eagle users and so on. And we're there to answer questions, and that's what we do. We also do the AstroWorld Picture of the Week, which we do every single show. We critique some of our viewers' pictures, and we kind of say, okay, maybe a little tweak on this, maybe a little tweak on that. We are not experts by any means. I don't want to say that we are, because we're not. We probably learn a lot more from our viewers than we do ourselves. So it's a really great collaboration of people that are like-minded and do basically, as visual astronomers are able to come as well, but we basically focus on astrophotography, and we just broke 1,000 subscribers. And let me show you.
Congratulations.
Yeah, we just broke 1,000 subscribers on YouTube, and we're looking. We're almost 1,100 now, so it's moving. So if you want to know anything about AstroWorld and what we do, or a little bit more, let's see if I could share my screen here. This went to, let's see. And oh yeah, I do it this way. Sorry, it's been a while since I've done this. So
sharing your screen. Okay.
Yeah, no, I apologize.
So it looks like we're looking at OBS.
There
right
we
now.
go.
There we go.
There we go.
Okay.
And so
Great.
this is the AstroWorld website. So www.astroworldweb.com. You could actually go right here, and it'll show you when we're online and what guests. We have a ton of guests that come on all the time, from Masters of PixInsight, Ron Breacher, Juan Keller, and Peter Proul. Scott, you've been on, and you're getting ready to make your second appearance on the show. And who else did we have? We have plenty of astrophotographers: Sean Nielsen, Amy Astro, Adam Block, Chuck Ayub from Chuck Astrophotography, Doug. I could go on and on. But we're starting to get more and more. Colin Haig is going to be on from Diffraction Limited. Tomorrow night we have Roland Archer that's going to be on the show, and he's going to be giving us a rundown on the Voyager acquisition software, which is going to be really, really exciting. And that's tomorrow night. But other than that, that's pretty much what we do.
That's awesome. So, the feedback that you give to the community, I think is, very much needed, because a lot of people, they're reading books, or they're just reading posts on cloudy nights, all of which is very useful. Okay. But to be able to interact with somebody live and ask questions And my goodness, to have your astrophotography critiqued live in a program, where you can kind of interact is really an amazing dynamic. Okay. When I was doing my early astrophotography, I know that I would have progressed so much faster as somebody said, well, yeah, okay, we can see that you did this and you need to work on your focus a little bit more. And you need a better mount, or you need to control that mount better, but there were a lot of unknowns for me at that time. And I was literally, working in the dark with a lot of astrophotography at that time as well. Those are back in my film days. I did have the privilege of seeing some of the first digital CCD work being done by amateur astronomers, and had met up with the people that started up the Santa Barbara Instruments Group company before it actually really launched, and saw some of their prototypes and stuff like that. So that was a real privilege. But my knowledge of operating a computer and stuff was still kind of, well, I'm not even going to say it was rusty. I just didn't know really what to do, except to just take notes and follow instructions of what people were telling me to do. But I think that the program that you're running today is great, and you have a real friendly and fun group of guys running it. So
yeah,
and that's what's going to make it popular. So
yeah, and if you ever go and take a look on the show or look at we do keep it very, very light. So we do keep it technical sometimes. Usually Wednesday nights is our more technical show. Friday nights is more geared towards the beginner. And for people who are just starting out, okay, I want to get out and I want to do Nightscapes, or I want to buy a tracking mount, a Star Adventurer or a Skyguider Pro or something like that, and just start. Somebody said it earlier tonight. It doesn't have to cost an arm and a leg to do this. You don't have to spend.
Very true.
You don't have to spend $25,000 to get a decent picture. I mean, you don't have to do that. You could do this with the stuff that you have in your house, which is already there and ready to go. Just get your DSLR, get out there and start shooting, because there's nothing more gratifying to me that when you take that first picture and you say, hey, I took that. That's cool. It could be the blurriest, ugliest, nastiest picture, but you know what? I took it, and it's cool because I took it. And remember, I think somebody else said it tonight too, the over-processed stuff and all like that, there is a place for that, and the oversaturated kind of thing. But it doesn't matter what anybody thinks about your picture besides you. It doesn't matter. You are the artist, and you are the person that's got to be not complacent, but understanding what you did, how you did it, and if it's pleasing to you. Don't let anybody else tell you anything different, because you know what? Yeah, you know what? Maybe focus isn't very, it needs a little touch here, a little touch there, but you know what? It's your picture. And if you're happy with it, stay with it, because it's just going to get better.
That's right.
Hey, Daniel, can I add something to that?
Absolutely.
Just really quickly. Social media, affects a lot of things. And like I remember when I started posting some images on social media, and if they didn't get as many likes as, say, another image that had all of the type of processing or just a different sort of look, I'd get dejected pretty easily.
Okay.
The moment that I followed the advice you just gave, where you're like, the image, you have to like the image, doesn't matter if anyone else likes it. The moment I did that, that's when my images, I would say, took off, as far as I started to like the way they looked, what was coming out. And when I would post a few of them, a few others might like them too. And I didn't look for numbers. I just appreciated the kind compliments that I would get if a picture just happened to speak to somebody. So definitely important, I think. Real important point you hit on there. I appreciate it.
No, yeah, I and that's something that we preach about on the show quite a bit, is where, feel free to send us your photos. We'll tell you, we're not we're not going to beat you with a stick on it. You know, it's not going to, we're not the pixel peepers. We're not, you know, we can be if you want to be. But, you know, we're more like, okay, how do we build the community to get a better result if you don't like the result you already have? That's the whole thing. And I think you're right, Adrian, that you say, you know what, once you stop worrying about what other people are telling you and how to do it, because social media could be the detriment to everything you put out there, because it could just be a complete nightmare. Because if you're very sensitive in that aspect, then you may stop doing the astrophotography, and that's something none of us want, because the pictures that are out there and the pictures that we've just seen tonight from the landscapes and everything, have just been blew me away. Totally blew me away.
I agree. Well, gosh, Daniel, thanks for coming on to Global Star Party again. You are welcome anytime. You know, you're in our group. And so if you have something new that you want to add about AstroWorld, or, you know, even have on a guest to come on with you, we're very pleased to do that. And we'll do our best to promote what you're doing. So I think that's wonderful.
That's awesome. I appreciate it. Thank you so much for having me on. Thanks for listening to me babble. I know I tend to do that, and if you
I do too.
It's just one long sentence sometimes. It doesn't stop. Trust me, it's something I've had to work on for 51 years.
51 years now.
And it's now I've just given up. It's not going to work. It's in New York.
Tell us also a little bit about, just take a couple of minutes to talk about Camera Concepts. You have been there for, and interacted with them for a long time.
Yeah, well, I've known Jeff, the owner of Camera Concepts, for, well, probably since I tried to start talking slower. But you know, the whole with that. So Jeff and I have been friends for a long time, and I probably bought one of my first telescopes from Jeff. And Camera Concepts has been around since the 80s, and he'd started off selling cameras and went to telescopes. And once he started getting to telescopes, that's when I joined AOS, which is the Amateur Observer Society of New York. I know Mr. Levy, if he's still there, knows quite a bit of our members from the Alcon quite a number of years ago. You know, he asked me, he's like, oh yeah, you know telescopes and you know astrophotography a little bit. Why don't you come and work with me at NEAF?
Nice.
Yeah, so it's like, oh, NEAF, yeah, I've been there a bunch of times. Yeah, I'll come work for you. Little did I know what I was getting myself into. It was a complete, I mean, NEAF is a monster show. I mean, you're just running around going crazy, talking to people and everything. Scott, you know,
of course.
Oh my God, it's crazy. Yeah. There's not some people running in and out from Thursday to Saturday if you're at NEAC. And unfortunately, NEAF is not going on right now.
Yeah.
But whatever the case may be. So he asked me that. So one NEAF turned into two NEAF, turns into five NEAF, turned into 1 day a week. And now I'm working with, I've been working with Jeff 1 day a week plus extra for the last 6 years or so.
Oh, wow. That's great.
Yeah. So great. I do all the run stuff, like the any repairs, collimations, cleanings, software upgrades. I give people ideas on how to upgrade their systems if they want, or if they're just coming into the hobby. I don't even like to call it a hobby. I call it a lifestyle, because it really is. It's not.
It really is.
It's not even a hobby. I mean, for those of you out there know how deep this rabbit hole can go. It gets pretty deep, and you know, I try and first thing I tell people, what's your budget before I tell you anything. I'm not telling you. I'm not telling you anything until you tell me how much you want to spend, because I could make you spend 30 grand easy. But it's a lot of fun. Working with Jeff is a lot of fun. Working in the business that I love, and it allowed me to take this picture behind me. This is one of mine. The Heart Nebula. Yeah, that's one of mine.
Beautiful.
Yeah.
Beautiful.
But yeah.
Well, that's great. Well, Daniel, thank you again. And we'll move along, but
Yeah.
hopefully you'll be back on Global Star Party soon. So
Yeah, whenever you want me, I'm at your disposal. So
awesome. Okay, wonderful.
great. Thank you so much.
Okay, thank you. Well, up next is we will bring on Stephen Edberg, and I often call him Dr. Edberg, but I have been corrected a number of times from him. Steve is a great friend. When I first met him was he'll know, I think he can point out the exact year, but it was in the 1980s. Before Halley's Comet had arrived. So this is about 1983 or 84, something in that area. And we had a mutual friend. His name is Mark Coco. And Mark worked at Celestron. And we were a Celestron dealer. This is back in my days when I worked at a place called Oceanside Photographic Center that became known as Oceanside Photo and Telescope, or OPT is known to a lot of you today. I had just started to put together community-based types of programs, putting on little star parties, putting on little lectures and stuff like that. And I talked to Mark and I said, I invited Mark to come down, and he says, well, who else are you having to come speak? And I said, I don't know, who could we get? And he mentioned Steve Edberg. And I said, wow, tell me more. And, he was telling me he worked at the Jet Propulsion Laboratory. And I'm going, oh my God, we could have a scientist from the Jet Propulsion Laboratory come to our store and talk about what's up in the sky and talk about Halley's Comet. And, he said, well, I'll ask. And so Steve did come down. And since that time, Steve and I have worked together on various projects. But he is someone, when you know someone like him, where he is so accessible to amateur astronomers and has done so much for amateur astronomers, but he's done so much in the professional world. He was a professional astronomer working in observatories, both in the United States and Australia, and maybe other parts of the world. He had worked, I just know a few things he's done at the Jet Propulsion Laboratory, like working on the Galileo mission, working on the Cassini mission, he has insight into the inner workings of the universe like few people do. And so I'm not trying to make his head too big, but I can't say enough about this guy. He was a great guy, and we're really, really honored to have him on Global Star Party. Steve, thank you for coming on to our program.
Okay, can you hear me?
There you go. We can hear you, yes.
Okay.
And I love your NASA shirt, so.
Good, thank you. Thank you for a very nice introduction. Actually, Scott, it's been a great pleasure working with you and playing with you over the years. It's been a lot of fun, so.
I likewise.
Well, so Scott asked me to talk about the expansion of the universe, and not so much that, but just the Doppler effect. And of course, when I do things, I try and make sure it's complete and able to share. So I started pulling together the demonstrations you can see over my shoulder, and I'm afraid that it is the limitations of the camera that I have on my atop of my screen right now that's going to prevent me from doing much with that, though we can try and you can tell me if it's working or not. But I am backed up with a few slides from PowerPoint that I'll use to discuss it. And the question Scott asked me was about the Doppler effect. And just as an example of how I like to be complete, I want to say, and be complete then with what could be considered the full name of that it's the Doppler-Fizeau effect, also known as the Doppler shift in more common and quick language. And so I'm gonna kind of begin at the beginning, because I could do a lot of different things that would just be hand waving, but I'm hoping that I can give you enough background, if you don't have it, that you'll be able to think about this more clearly and even apply it to your own observations of the sky. So what I'm going to try and do here is change, and maybe Scott will have to do this for me, but I'm going to start with a full screen, and at least try it once I get there. There we go. And
Now, if you're trying to share,
I am trying to share. Do I?
Okay, so there's a green button at the bottom. It says share screen.
Okay.
And you click that, and then you're going to see a display of your other programs that you have on your computer.
Okay. There we go. Got
And
it.
you click on that, and then you commit to it. So.
All right.
And we'll see when you start sharing. I can unshare you, but I can't share you.
Okay. Got it. All
There we
right.
go.
So there we
And if
go.
you want to bring that into presentation mode, you can do that too.
I'm doing it. There we go.
Perfect.
All right. So let me go on. I'm going to start actually with the spectrum of the sun. Something simple, something that was studied even by Newton, though he didn't get very far with it. He said that he showed actually that all the colors combined to make white light after he'd spread out the sunlight with a prism in his room, cutting a slit in the curtain, letting it fall through the prism, and then putting the light coming out of the prism, which was a rainbow, back through a different prism and combining it back. And sure enough, it turned out to be white. Good science, but for a reason that nobody actually takes the time to explain, and it took me a long time to figure it out, and I'm not going to share it with you. We can do that another time. I'm easily distractible. He did not see what we call the Fraunhofer lines. Those are those black verticals that you see at the top of this picture. And all of those are representative of the various elements in the sun. And I've tried to show what those are with a minimum of effort for comparisons. So, for example, this actual set of lines in the sun right here, it's called the magnesium triplet. And here is the magnesium spectrum in the laboratory lined up with the sun. Now, you might be wondering, and you would be very good to wonder, why am I showing like bars of light for the laboratory and dark lines in the solar spectrum? And all of those are actually more simply due to the fact that we have to use a very thin razor sharp slit to let the light through to be able to get this resolution. And that's part of the answer as to why Newton didn't see the dark lines across his solar spectrum projected across the wall. There's a more subtle reason as well. If you look at hydrogen, you can see this is probably the beta line, H beta, that you sometimes hear about for looking at deep sky objects. Here's the H alpha line that we certainly look at the sun in, and can also look at these objects. Sodium has a very prominent golden line, I'll call it. It's right in the yellow-orange, and it's actually a pair in this much higher resolution solar spectrum. And the difference of these is due to the fact that in the laboratory, we're exciting the element itself to glow in a vacuum tube. So it's just the pure light, ideally. And when we get the sunlight, we're actually seeing elements in the sun's atmosphere that are cooler than lower levels, and they're absorbing exactly the same wavelengths, colors of light. And so we see that. This was first seen by Fraunhofer in around 1813 or so, and he cataloged a bunch of them. And in this picture, you can actually see, you can't quite see the A line, but it's deep down over here on the right of the sun. This is probably B. This I know, being hydrogen, alpha is the C line. D1 and D2 are the ones, actually the redder one is D1. The yellow, on the bluer side would be D2, and helium D3 is illustrated. Where did I put helium? I thought I had helium on this. It's not here. Darn. I'm going to show it to you later, I think. Anyway, there's one called the D3 line, which we usually only see in emission as a bright line on the sun, or actually above the sun in prominences. And so these are all named. You can barely see them, and maybe not at all. Actually, this is a pretty good copy right down here. These are the calcium H line and K line, and they're going to come back to haunt us in just a few minutes. So we can identify these. We have these lines, and besides being fingerprints for all of the elements, and helium was discovered in the sun before it was discovered on Earth, they are also a way for us to measure the Doppler effect. So I've already mentioned the emission and absorption spectra, so I'm not going to go into more detail on that with you, just to show you and remind you that a hot gas, hot element, if we put it in the lab, will have an emission spectrum. A cool gas with light, either from tungsten light or sunlight coming from the deeper photosphere, going through a cooler gas, will make an absorption spectrum. And even reflected light off something like the moon or a planet will make an absorption spectrum that matches the source light. So this, for the sun shining on the moon, we see an absorption spectrum. Where the moon gets more interesting, besides subtle differences in color, is in the infrared, when you can start to identify minerals that are very different from what you would see in the sun, for instance, because the sun pretty much vaporizes everything. When we look at gaseous nebulae, the hydrogen regions that are usually glow red, mostly because of hydrogen, but because of oxygen and nitrogen as well. And again, there are subtleties I'm not going to bother with. There are also, as you can see here, neon, helium. Here's some more oxygen and more helium, as well as more hydrogen visible in this spectrum of the Omega Nebula. But it's primarily red because there is so much red, the big emission being hydrogen, with oxygen and nitrogen occasionally adding a bit more in that part, nitrogen especially in that part of the spectrum. So Christian Andreas Doppler was a mathematician and physicist from Austria. Armand Hippolyte Louis Fizeau was a French physicist, and they independently realized that if you had some way of measuring, and here were these dark lines in the spectrum of the sun, if you had some way of measuring a fixed wavelength, it would change its wavelength or frequency. They're interchangeable, meaning difference, but for our purposes, any one very, very narrow color, that helium D3, for instance, is a very bright gold line in the spectrum of a prominence, or hydrogen is a very prominent line in a gaseous nebula. And so if we look for motion in those, we may actually see a change in the wavelength, because either Earth is moving towards or away, or the nebula is moving towards or away. And so we can see that actually by reflecting sunlight from Saturn and from its rings. And this is a really, actually, I went looking to find one. This is a very interesting combination here. I have added this black line here. I should have made it a little bit more apparent. That's the one between the Fe, that stands for iron, and the Ca, that stands for calcium. And this is, again, the reflected spectrum of the sun. These numbers are actually in angstrom units, which have been retired, but I grew up on them. This is actually would be 612.845 or decimal 8.845 nanometers. So this is 612 decimal 845 nanometers. So we're in the red portion of the spectrum, of the solar spectrum. This is Saturn in the center section, as you see illustrated here. And this is the rings. And notice, if you compare it to my added black line, and I should have picked a different color for that, you can see that the separation between this very intense, meaning dark, spectral line in the sun is at different places with respect to the ring, the planet. It's even tilted here, and the ring on this side. And what we're seeing is in this on this side is a red shift away.
That is
from the
cool.
reflected light of the ring. Saturn itself is reflecting light at that spectral wavelength and is also red shifting it because it's rotating. And here we're seeing a blue shift, and a blue shift on this side of Saturn. The 0 point would actually be right about here. So this is, I think, a very good, very nice illustration of this. If there was enough resolution in this spectrogram, we could actually see tilting along the rings with greater shift, greater red shift on the inner ring and lesser red shift in the outer ring due to the orbital motion of the particles that are reflecting the light. It's really an amazing picture, even though it doesn't quite go to the full resolution, but it shows what's possible. So what I want to do, I'm going to take a break here. I'm going to shut off the light for a minute and ask if you can tell me if you can see the spectrum that is actually presently showing. It's a helium spectrum, and that's why I wanted to show it, if I could, partly because it was bright enough, and it doesn't look like it's big enough. You should be seeing some color over here, and if you can't, I understand, and I apologize. Getting this set up was sort of.
Can you pull your camera off your computer?
I can do that.
Yeah, maybe
I have some range for it. Let me try.
Okay. Move down a little bit.
Okay. Let's see, because I can't see what I'm doing now. So. Can
Yeah,
you
we're
see?
just seeing
Can you
black
see
right
a spectrum over here?
No, we're not seeing it yet.
Do you see any light at all?
No.
Okay, that's telling me something too. Oh, okay. Let me see. Everything looks like. Can you see my? Here, wait a minute.
We
Let me
see
try
you.
this. Okay, you can see me. And
Okay.
can't.
Oh, now we're starting to see a little bit.
What do you want me to do? Move right or left?
Move to
Oh, I
our
see it.
right.
Now I can
There you
see
go.
me.
Okay.
Okay. I want you to be looking on the left side of the bright white. There, it's actually not white. It's really kind
Here,
of
let
golden.
me stop your screen sharing, and then we'll get to a full screen. There we go.
Okay. Okay. The downside here is that with the magnification, it's just too bright, oddly enough. I rarely complain about something like that. But I'm afraid it's all lost in we're just saturating the camera.
Right.
It's not handling the light. Let me try one other thing.
Okay.
And I have to just wiggle and settle things down. I'm going to turn back the light on in the room, and
Oh, there
now
we
you
go.
can.
Yeah, now we can.
Okay.
Interesting.
So what you're seeing there is a violet line that's closest to the bright white one in the center. You are also seeing next to it, outwards on both sides, a greenish line. Then there is the bright yellow line that is the brightest on either side. And that yellow line is actually D3, as it's called by solar physicists. And then there's a red line, which I can't even see. I'm sorry, I'm tilting this, but it's just too faint. It is visible here. But those are emission lines by excited helium. And so you're getting an idea at least of what those look like in the real world. I'm going to do one other thing. I don't know if it's going to work, but now I have more hopes. So if you'll bear with me, I got to put this down again.
Okay.
And I want to show you some real live absorption line. And if you have mercury street lights or high pressure sodium, you can also see that. Now I'm going to turn this down. And in fact, I'm going to cover up this so that it's not a distraction. And let's see what we can see here. No, it's, again, it may just be too bright, but bear with me.
Oh,
Okay. Right now, if you look in the area of the purple circle,
yeah.
there is a spectrum blocked by blocked partly. I'm gonna let me get something to point better with, because I can actually see what I'm doing now. You're seeing a spectrum that runs from blue to red on this side, and there is a black dot in front of it.
Yes.
And actually the same is true on this other side, but it's not quite as clear. Now, watch what happens when I move this off that area. And notice, first of all, it gets very bright, but you are actually, that there is, in the spectrum that you're seeing over here, there is actually a dark zone right across the center of it. And there's only red and blue visible in the lower portion where the purple is. And the whole section that is green is gone. And that is actual absorption. If you have a diffraction grating or a prism you can look through at a high pressure sodium light, you are seeing the absorption of sodium in that spectrum. That's more complicated too. And I don't want to keep spending a lot of time on this, honestly, but I did want to try and give everybody a chance to see this. So I think we'll chalk it up to try a different way next time and go on from there, if you don't mind, because I don't want to blow my time here. Okay, so I'm going to go back to my screen and so we'll go on. I hope.
Okay. Yep. You're back.
Okay. Page down. I'm not, oh, there we go. All right. So when we look at galaxies out in the universe, we can see absorption lines. And you might remember that I mentioned and tried to point out, though they were really hard to see even on my slide, the H and K lines of calcium. And they're visible in this spectrum of NGC 221. Anybody know what that happens to be? This is a test. That's M31.
Yeah.
And
right.
You can see where that position is. Notice that it has been indicated that that the velocity, the Doppler shift, is minus 200 kilometers per second. And when we go to the NGC 4473, which is in the Virgo cluster, it's plus 2,300 kilometers per second. NGC 379 is at 5,500 kilometers per second. Some unspecified galaxy in Ursa Major cluster, over 15,000, and in the Gemini cluster, over 23,000. Now, these were all done in the 1930s. That would have made them, they were made with the 100-inch at Mount Wilson. Sorry, folks, it really is 100 inches, 2.5 meters for our international friends, by Milton Humason and published in the Astrophysical Journal. And Hubble himself, Edwin Hubble, made the first plot and published it in the Proceedings of the National Academy of Sciences in 1929. And I picked that out. So already the pictures that I'm showing you are beyond what he did. He was working with Humason further on. But you can see on the right in this figure, the first hint that distance and speed away means something, because that's what the velocity distance relation is. He was wrong in this plot. This value, if you plot what's called the slope of this line, is about 500 kilometers per second per megaparsec. In other words, it's fast per million, per 3.25 million light years. We now know that number is right around 70 kilometers per second per megaparsec. And we know that because, here again, just some more pictures, a little better. You can see here are the calcium lines, and I should have taken out that first one. In fact, I didn't need to do that, but you can see the galaxies in here a little better than that previous slide. Sorry. What we see now is done digitally. Here is a spectrum of a quasar near, well, I don't know, 5, maybe 7 billion light years away. This redshift is 5.82. What that essentially means is that a spectral line, this is hydrogen, but it's way, way into the ultraviolet. It's called Lyman alpha at 121.4 nanometers, or that 1214 angstroms I was mentioning earlier, deep in the ultraviolet, has been shifted into the near infrared. These wavelengths are, again, in angstroms. This is 800 nanometers, 800 change. This is 800 nanometers. And this is way out at about 8,300 nanometers, or 830 nanometers, sorry. And this is a Hubble plot, one of many. I tried to get one that was out at going as far as 5.82, but nobody's publishing them. And there aren't that many objects that we know at that distance. But in any case, this is what a Hubble plot looks like. And this is much like the one that has been used to determine out in this range why we think there is dark energy. And Hubble's original one that I showed you over there is somewhere right down here at the bottom. It hardly got anywhere at all. But what he found back and reported back in 1929 had started everything that is leading to what we know about the universe now. So I think that's all I have. Yep. And just a more complex absorption spectrum for you to ponder. And Scott, unless we think somebody's going to have some question about what I've shown, we can just go back to the talking screen.
Okay. I think people are getting a great education from you, Steve. So no particular questions right now, but certainly You can do spectroscopy as an amateur astronomer. There are companies that make spectrographs for amateur telescopes. But are there simple ways to do it that are low cost, Steve?
Yeah, let me tell you, there are very simple ways to do this. And I have been doing it since I started doing it in college, for a class actually, but it was my own figuring out, using a little bit of what I read in Sky and Telescope to get started. And that was essentially putting a diffraction grating in front of a camera lens and doing star trails. And basically you can take, if anybody knows what a 35 millimeter slide is anymore, I know our first Francois does.
Yes.
Very nice pictures, Francois. You can get those commercially, at least in the United States. Rainbow Symphony, it's called. They're on the web. Will sell you some that are reasonably efficient for $1 or $2 a piece. And I'd tell you to get two just in case you make a mistake, because they're a little bit fragile. But you cut that down, put it in front of your camera lens, and start with bright stars. That's the key. But bright stars, and bright stars means first magnitude. But a star like Sirius, Vega, and Antares all will show spectral lines. Betelgeuse will too, and to a greater or lesser extent. But go learn some of the spectral classes of stars and experiment, and it can be real. It's really a lot of fun. You can also actually, again, with your second Rainbow Symphony diffraction grating, you can, though I have to tell you, they do need to be more efficient than that. But if you were to dig out and put it in between your telescope objective lens and your camera sensor, whatever type of thing you use, you can actually get a spectrum of the Ring Nebula, for instance, and you'll discover it has a spectrum that is a bunch of overlapped rings rather than just a continuous one or something like that. So it's a lot of fun to do. Same thing with it's even easier with the Orion Nebula, and you'll see that it is quite different for a spectrum from all the other stars in Orion, and those stars are generally bright enough. So crank up the ISO if you're using a digital camera, because that will also serve for the to counterbalance some of the inefficiency of that. And then if you find this intriguing enough, there are a number of commercial gratings that are available, but we're talking costs now getting up in the $100 to $200 range, which you can do the same thing and more with that equipment, and they're usually more efficient too. But it's something that I keep doing, and I'm still trying to get another meteor spectrum, and those are hard, let me tell you.
That would be difficult. There's a question. There's a question from Tarek in the UAE. He's wanting to know, does the spectra of the sun change?
Yes. Not very much. It's subtle. For example, in fact, let me go see if I can get just the spectrum of the sun up here again. And so I can just point at it. If you were to observe, this is hydrogen alpha here in the red, and you notice how wide it is. If you catch a solar flare occurring, you can see that on occasion become visible as a brightening in the hydrogen alpha. And in fact, some of these other very dark spectral lines scattered across the spectrum, especially if it's a very bright flare, one of the so-called white light solar flares, like the Carrington event in 1859, you will see a lot of these get lighter. You can also, one of the tricks, here we're getting deeper into this. I could spend hours, so I gotta control myself. I can't pick it out for you. It's a little hard to see on even here, but there are certain spectral lines in the sun. Iron has a number of them that are actually magnetic sensitive. And with a polarizer, and I've done this, you can actually take a picture of the spectrum and keep the line gets split by a strong magnetic field. And a strong magnetic field, had there been a sunspot in this, where the slit of this spectrograph was placed, you would have seen a dark horizontal line, not the black ones that you see in the strips, but in the middle of each one of these red band, and each one of these color bands running sideways. And that would have been the spectrum of the sunspot. And near the sunspot, you can see magnetic field lines either be one stronger or one and the other weaker, or the other way around, depending on the polarity of the magnetic field of the sunspot. Move a different sunspot, those two can reverse, especially if it's a pair of sunspots that are magnetically connected. So yes, the sun spectrum does change.
Interesting. That's cool. And I suppose that's true of also stars. Is that right?
Oh, stars
More
get even
difficult.
more interesting.
Okay.
With stars, they do have flares, and you will see some stars develop bright spectral lines in their spectrum, much as I described for what's happening in the sun, but you can see it from light years away. We have not, fortunately, had any solar flares of that size and wouldn't anticipate any from the sun. But red dwarf stars are sometimes very magnetically active, and they will have brightenings that are all a stellar flare. Also, variable stars that have a wide range typically also not only change their color, but they would, because you're seeing different levels of the atmosphere and temperature, you will see the spectrum change as well. And so that's something that you can monitor even in Cepheid variable stars and Miras. So yeah,
Awesome.
stars do it too.
Awesome. That's great. Well, thank you very much, Steve. We'll probably have to have another program that deals with this because it is through analyzing spectra, and this is something amateurs can do with your telescopes. There's software out there. There's a package from a company called RSpec that, and I put a link in chat about it, but you can see some amazing spectra in stars, and not just first magnitude stars. I've seen him do it with much fainter stuff, and it is really cool to analyze what's going on in the interiors of celestial objects. So thank you so much, Steve.
Scott, I have to add to that Tom from RSpec is just incredible with his support for teachers. He goes out of his way to help students work on projects with spectra, and RSpec is really an approachable package for amateur astronomers and for teachers.
Yeah, and Tom Fields, who creates this RSpec, is just so enthusiastic and so amazing in his presentations that it would make almost anyone want to get started. But we've got a great primer here from Steve Edberg, and
Exactly.
It is something that it makes you want to go beyond just looking at beautiful objects in the eyepiece.
Yeah, let me add actually one more thought, and that is, thanks to Francois, I will say you can also get comets. I've gotten comets as faint as magnitude 6 through the telescope or just through the camera lens when we have a really nice bright comet. And so there you can see molecular emission lines. That's a whole separate story from anything I've told you today. And just, you can even tell sometimes how dusty a comet is by what you're seeing. You can separate the spectral lines of the tail as well. It's a whole different way of looking at the sky.
Absolutely. Absolutely. I did point out, Steve, that you conducted one of the early Pro-Am projects, which was International Halley Watch. That was my first introduction to doing any kind of science. And Steve wrote the book on how amateurs could participate in the observation of Halley during its 85, 86 apparition. So I'll also add that Steve Edberg is an incredible visual observer. He is the one that taught me how to see faint through a telescope. And so I have a lot of gratitude to him because I was able to see tons of faint galaxies and to see galaxies visually with my own eyes was my dream to do in amateur astronomy. And so Steve made that possible for me. So thank you very much, man.
My pleasure.
Okay, so up next, we're going to go to John Johnson, who is one of the top guys, maybe the top guy of the Nebraska Star Party. And you guys held, I think, the first in-person Star Party in the country last year with the Nebraska Star Party. I mean, that was formally announced and everything. There were people sneaking out and in groups and stuff to do some stargazing, but Nebraska Star Party did go off last year, and of course it's going to go off again this year. So I'll turn it over to
me. Okay, can everyone hear me? Can you hear me all right?
Yes.
Well, I know we've run way over, but I just have to pass along some thank yous and some just, oh, wow, what a neat time. Of course, first of all, Mr. Edberg, I have met you. I'm sure you don't remember, but at my very first Astronomical League convention in Dallas in 1980, I met you there.
Oh, really? Okay.
Remember that? Both of us had a lot more hair back then.
Yes, we did.
I sure did.
Yeah, I do have like a little bald spot starting right here. So,
but what I remember so much, if you don't mind, if I can call you Steve.
That's fine. Thank you.
Wasn't it that was when you introduced that they were going to start having the Leslie Falieres Observing Award? I maybe my memory's failing, but I was so impressed with your talk on that, and of course rubbing shoulders with some of the other amateurs. That was truly my first national convention, and to meet guys like you, and I think Walter Scott Houston was there, and of course Jack Marlin from Lumicon and Clay Sherrod. So that was where I really started to get a kick out of meeting the national scene, and I'll never forget that. Another connection, I think, Steve, I'll just mention quickly. I think you have worked with Gianluca Massi, haven't you? The Italian. So. I thought he said he had met you. He's quite quite an astronomer over there in Italy. But anyway, the people you meet, Virtual Telescope Project.
No, but might have been something else. The names.
Yeah, well, he's Google him. He's an amazing guy. In fact, what prompted my memory cell was who was it? Francois, that had a picture of Hale-Bopp. That was probably my first successful, sort of what I thought, comet picture with film. And that's when I met Gianluca Massi in 1997. I was headed over to Italy for a Naval Reserve event, and we hooked up, and we've been lifelong friends ever since. But, Anyway, just
Nice.
dropping names, but okay, back to the subject at hand. Yes, Nebraska Star Party. We did it I think we were the first one last year to have a quote star party.
Yes.
And it went off extremely well. We had one of our best years. I think we ended up with about 375 people show up during the week. And it went very, very well, other than you never get enough of nice, clear nights. But hey, that's why we always advertise you have to come up for at least 3 or 4 nights to make sure that you catch the night. And when it happens, it's unbelievable. It is some of the darkest skies in the country up there. And we're planning another big one this year. The dates are going to be the 24th of July through the 29th, the last full week of July. And I don't know, Scott, if I can make this work or not. I've never been very good about this sharing thing. If I try, I have about a 2-minute trailer that was from a couple years ago. Well, let's give it a shot.
Okay. And I'm also sharing the Nebraska Star Party website.
Okay.
John was trying to describe how dark it is out there. Unless you've been to a really dark site, you really can't appreciate what that feeling is like. When you can actually see your shadow cast from Milky Way light. That is amazing, and you can do it there. So.
Okay.
All right, so you're sharing right now.
Do you have it? Okay. Now,
hold on, let's give it a moment here. Yep, okay, you're good.
Can you hear it? It's kind of loud.
The audio part's not coming across very well, but the video's fine.
The sound isn't coming through?
Before you share, you have to click a little box that says share system sound. It's going to be on the left hand. So if you want to stop sharing and go back and share again, we'll let you do that. Here, I'll unshare you.
Unshare it.
Back. Okay.
Okay.
Now try that again. So you're going to click the green share screen button. And before you commit, okay, you're going to see a little box off to the left-hand bottom.
Share sound.
Share sound. There you go. And then you can start your video over and it'll share it.
No, that's the website. Here, let's try again. Okay, is it there?
You're still on the website. We see July 24th through 29th.
Yeah.
I can unshare you if you'd like.
Yeah, unshare me, because that seems to be, once you do it, I can't go back. Okay, let's make sure this is up. Okay.
How many years has Nebraska Star Party been going on?
This will be our 29th year.
Wow. Okay. That's a long time. Okay. You're back where you were.
I tell you. Okay. We'll make sure that. Okay. You'll have to unshare me again, it looks like.
No problem.
Okay. Let's get the.
Click on the dialog box that has the video.
Yeah.
Okay, I think you got it.
Okay, we got it. I'll back up. Okay.
There you go. Now you got. Now you're cooking with gas.
How's the sound?
Yep.
Okay. We have a gentleman down at Lincoln that's quite the drone photography guy. So
I can actually hear sound coming from my sub now, so it's really good.
Yeah, he put some really nice sound. Hey, look who's there! Look who's there!
when I eventually make it to, that's a beautiful picture. When I eventually make it there, I know where I'll be setting up.
We have plenty of room.
Oh, yeah. Look how dark it is, all the way down the horizon.
Cater meals in the evening. At the high school in town on Wednesdays for speakers. I'll mention who we got in a second here. Vendors, swap meet, photo contest. Okay,
Okay. I'll unshare
right
you.
now, and then I was going to bring. Let me see here. Okay, let's bring the website back up. Let's see if that works. Okay. So is that
Yeah, that's the website.
back up there? Okay, there's the website again. And there was this, yeah, we have registration is open. You can click and either sign up online or download a PDF form. There's the beautiful beaches up there, Lake Merritt Reservoir. Absolutely gorgeous place to bring the whole family and water ski, swim, have three-legged races, whatever. Okay, there's an overview of it. Now, as I said, registrations are open. It's the July 24th, 29th. We've selected a couple of our guest speakers. One of them is going to be this gentleman, Stephen Ramsden of the Charlie Bates Solar Observatory.
Oh, yeah. Yep.
Stephen's going to be up there as probably our keynote. And thanks to me watching Global Star Parties and Scott being so generous inviting me on, here's one of our other speakers.
Levy
and the Stars. Those of you regular attendees, it was GSPs. Libby and her mom are going to be up there, and she's just thrilled that we've invited her to come up and actually give a talk. We really emphasize the whole thing as a family gathering and to bring children and young adults up to experience what we have, and we felt that Libby would be an excellent example of up and coming astronomers and maybe fire some interest in some of the other young people attending. So, and we're still trying to decide on what other speaker. We usually have 3 keynote speakers plus the other things, like I said, that go on at the high school on Wednesdays, and plenty of dark skies when the weather cooperates. You just never know, but it is we're getting a lot of excitement, a lot of publicity from obviously you, Scott, and various if those that are members of the Astronomical League, if you look at your March Reflector magazine, we have a nice ad in that issue this month. And so anyway, is there any questions? I know I don't want to spend a whole lot of time because things are running over here, so I guess
but people were generally impressed with the video, and I think that you're going to have some people from the audience coming to the Nebraska Star Party. There's also people that wish that they could go, but
I know
they have other commitments.
We're since we opened up, we've been the registration has been open just a little over a month, and we have I checked today. There was we have 50 registrations so far, 50 people registered, so we're on our way.
Yep, and Explore Scientific is committed to participating.
And yes, Scott, appreciate that, and we look forward to I think Kent March for sure, and we'll see who else.
Yep. Right.
So.
Right. Well, that's great. Well, thank
Anyway.
you very much, John. Thanks for
Great.
hanging in there, and thanks for coming on Global Star Party. as
Not
many
a
times.
problem, and we'll drop in again here
Okay,
sometime later.
good enough. Good
And
enough.
like I said, once again, I'm just always impressed with the quality of speakers, and obviously I was very impressed with Steve here and Karim, and I think Francois. I see, is Francois still there? Looks like he is. And I sent a message to Daniel. Was it Daniel? Yeah. Actually, I didn't realize he worked with Jeff Norwood there at Camera Concepts. Jeff, in his early years, was a big supporter of the Star Party too.
Yes.
Okay.
Thank you so much. Okay, so we're going to take a 10-minute break, and then we're coming back with Dr. Marcelo Souza down in Brazil. So stay tuned. Be back in 10.
I'm going to take advantage of my new coffee making machine and go get some coffee. I will
Famous
be
last
right
words.
back.
I
Yep.
just finished a cup of Earl Grey. That's usually my thing in the evening.
They've got Keurig cups with Earl Grey. I got to go get some of those.
Did you see Norm's first again? He managed to beat Harold just barely.
Yeah, very close.
Same timestamp. Same timestamp.
Yeah, there's a millisecond difference in there.
How are you, Maxi?
Hey,
We're
what's up,
supposed
guys?
to-
How's it going?
Supposed to do a Star Party. Oh, hi, Maxi. It's good to have all of you guys on today. It's amazing talks today, really. I mean, we always have great talks on Global Star Party, but every time I get to sit back and watch this parade of knowledge and inspiration go by, it's just, I pinch myself. It's just wonderful. So
It's
Yeah,
treasure.
I agree. Yeah.
It's free, and I think it's growing in steam as far as folks that are presenting or that are coming on to present.
yes.
By the way, how's my audio? Because once again, I've changed
Oh,
it to
It sounds really good.
Good.
Sounds good. Sounds good.
I think I finally have something that works. Hopefully you're not hearing much of an echo with the speaker I've got off to the side.
No, but I thought you were going to do some auto tuning there and, mix in a little bit of a beat and.
Nope, I left that stuff in the truck. I could go get it all, but it's been a while since I messed with that stuff. I switched over to doing photography, so that's it.
One of these days.
One of these days. But no, I'm glad this setup works. This mic obviously seems to work, and I'm using a real webcam. So yeah, I had to try and step up the game from just using the phone.
Scott, I don't know if you're seeing in the chat, but Norm seems to be not just. Norm knows he has a standing invitation, but he's now gone to volunteering Harold and Jeff to also be joining us up here on this side of the screen.
Oh, that's good. That's good.
We got to get them on.
Yep. So
Absolutely.
really,
I'll
any
be
of
right
you
back.
that are watching the show, if you love astronomy, you want to share your passion, show some of your images, show some live views, talk for a little bit, Global Star Party is a great place to do this. I've had people ask me, why are why are our talks, our time allotted so short? It came about with an idea that I had about doing astronomy outreach as like a pop-up event where you would go, you would just show up, a lot of cars would show up, people would run in, set up their telescopes, put some soapboxes down, and then astronomers would talk for 5 or 10 minutes while people looked through telescopes, okay? And I thought, well, maybe we can do that in the virtual world here, and it's worked out pretty good. But you get a healthy dose of astronomy education in just a couple of hours here on Global Star Party.
Oh yeah, it's fun
With some
and
fantastic speakers, so
It's great with the audience, just the back and forth and hearing from them. And then during the week, I get to see, Harold's moon pics, and Norm shares a few things, and you get to see their astronomy adventures. And honestly, most of them do more astronomy than I do. I don't get a chance to get under the telescope these days, so I live vicariously through everyone else.
Right. Yeah. I'm often the same deal, but when I do, I just love it, so far you've got to see David Levy, Terry Mann from the Astronomical League, David Eicher from Astronomy Magazine, Dennis Coy from Yerkes Observatory was on, Karim, who's talking to us right now, from the Royal Astronomical Society of Canada, Montreal Center, Francois.
Quesnel, yeah.
Yeah. How do I pronounce his last name again?
It's Quesnel. The S is, there he is. He'll speak for himself.
Okay, yeah.
Yeah, I lived for 2 years in Ontario, and everybody there was saying Quesnel. That seems to be the easiest way.
Quesnel. Okay.
And,
All right.
and there's a town in BC spelled exactly like my name. It was apparently one of my ancestors that went there, and it's Quesnel. So yeah, Quesnel is nice.
Daniel Higgins from AstroWorld TV was on. Of course, Steve Edberg, who you just saw give a presentation, and John Johnson. So up next is going to be Dr. Marcelo Souza. And I'm going to run the back here since we have a couple of minutes and fill my cup with water, and I'll be right back.
Sounds great. And I can't wait to see Harold's moon pics and Norm's nebulae. Oh, it's going to be fun. So Francois, are you going to come back? We're all loving your framing that you were sharing, and I think you and Adrian can do an entire clouds episode with your awesome landscape pictures.
Thanks. Yeah. We're not moving anywhere. So
Maxi had a fantastic picture he posted on Facebook the other day with the Magellanic Cloud visible up in the sky, and
yeah, I have too much material to share tonight. A lot.
My jaw dropped looking at that one. I was just sitting there. That, and then Francois started his with himself on a lawn chair staring up at the Milky Way. And I'm just sitting there looking at the streetlights outside my window going, no.
Wow.
All right, folks, I gotta go prep lab for tomorrow, but I will be watching on YouTube. Enjoy the rest of the evening. And Marcelo, Maxi, Adrian, I'll be watching yours from afar.
Okay, Karim, take care and
Good night,
see you
folks.
again.
Take care,
Astronomy
Karim.
is largely the study of
Enjoyed
light
it very
from
much.
distant places. Each kind of light carries different information that adds to our picture of the universe. The upcoming Nancy Grace Roman Space Telescope will detect a key range of light for studying the universe, visible into near infrared. Infrared, which starts at a wavelength of about 0.75 microns, will allow the Roman Space Telescope to make many critical observations. Roman engineers now plan to add a new filter, extending its range from 2 to 2.3 microns. This seemingly small change will make a big difference. Our galaxy, the Milky Way, is filled with bands of dust and gas that block our view of the stars behind them. Part of what makes infrared light so useful to astronomers is its ability to travel through this gas and dust. Infrared light has a longer wavelength than visible light, which means it is less likely to be scattered and absorbed by small dust particles as it travels over long distances. Upgrading from 2 to 2.3 microns allows astronomers to see through 2 to 3 times as much dust. This opens up much more of our galaxy to study, including surveys of small dim stars that glow mostly in infrared. Infrared is also good for studying the more distant parts of the universe. As the universe expands, it stretches the wavelengths of light along with it, a process called redshift. The farther away an object is, the more the light from it has stretched by the time it reaches us. Distant galaxies have all of their visible light shifted into infrared. Stretching over distance makes redshift one of the key tools for measuring the universe. Since astronomers can usually determine what wavelength they would see from up close, they can tell how far a galaxy is by how much the light has changed. Closer to home is the search for water within the solar system. Water ice absorbs specific wavelengths of infrared light, providing a fingerprint of its presence. As telescopes see farther into the infrared, they can see more of this fingerprint. If objects in the outer solar system, such as rocky fragments in the distant Kuiper belt, contain water ice, light reflected off them will have gaps where the water has absorbed that wavelength. This allows astronomers to detect water at much greater distances. The Nancy Grace Roman Space Telescope will form an unprecedented partnership with Hubble and the James Webb Space Telescope. With its extremely large field of view, Roman is uniquely equipped for large surveys of the infrared sky, allowing astronomers to identify interesting targets for more detailed study using Hubble and Webb's overlapping wavelength ranges and smaller fields of view. This collaboration will usher in a new era in infrared astronomy.
Well, we're back. Thanks for watching the first segment of Global Star Party. And now we get into segment 2 with Dr. Marcelo Souza, all the way from Brazil. Marcelo, how are you? How's everything going down there?
Hi. Hi, Scott. It's a pleasure to be here.
Good to see you.
I have an assistant here with me.
Ah, that's great. A young cosmologist right there.
Yes.
Mm-hmm. Wonderful. Wonderful. So how are your programs going in down in Brazil?
Yes, we had Carnival. Then this week we returned to work. And Maísa, olha, mano.
Yep.
Oh. Sorry.
Nice.
We have the Carnival, and this week we returned with activities because we have 1 week that's nothing work here in Brazil. Nothing work. And even with the COVID, we didn't have the samba schools in the streets and dance in the streets, but we had the holiday. But I saw a lot of people dancing also.
Oh, that's good.
It's impossible. And we returned this Monday, yesterday, with activities in school. I will show some pictures of the activities in schools. But
Okay.
I saw something that's fantastic in the presentation of Stephen, about the contribution of a person that I'm fan. And I included here some information about him. I don't know what you think about him, but for me, Milton LaSalle Hamilton is a fantastic person. And he saw, and Stephen, I think that was Stephen that showed images taken by Humason, and he made the calculus of the velocity of the galaxy. And he's a fantastic person. I will share here some information about him. I ever talk about him to my students because he's an example for all of us here. because he was, I don't know if it's correct my pronunciation, a mule skinner. It's correct, is that I said? A mule skinner. Is this not that you say? No? He worked very young with the mule to build the Mount Wilson Observatory. And during this work, he fell in love with the daughter of an engineer that was working at the observatory, to build the Mount Wilson Observatory. He married with her, and he worked in a farm during 5 years. I think that's more or less 5 years. And then what he would like to offer a better life for his family. And then the engineer knew that you have a vacancy at the observatory to work as a janitor there. And he was invited to be the janitor of the observatory. And 1 year later, he began to work with the astronomers. And 1 year later, he already worked as part of the staff of the observatory. Even he didn't study astronomy in schools, and he was not an astronomer. I think that's the first time in history that we had this. And he made a lot of discoveries. And he worked with Hubble, and the work that he did with Hubble that allowed Hubble to show that the universe was expanding. Here are images of Humason. Here is Humason working with Hubble and the biggest telescope of the Mount Wilson Observatory. Here is Humason, Hubble, and Einstein during a visit that Einstein made to the Mount Wilson Observatory. It's a fantastic image.
Yeah, this story is amazing. I mean, here he is. He's the guy has not even graduated high school. Didn't have
yes.
Right.
And he left the school. He left the school when he was very young. And then she moved to Los Angeles.
Amazing. And here he is with some of the greatest men of science in the world of all time. Okay.
Yes.
And making major contributions himself. So this proves that if there's a will, you too can be making contributions to science too.
Yeah, I ever talk about him to my students here as an example for everybody. Here is Humason. He was already retired in this picture. And we have a book. Where is the book? When I find, I took a copy of the image, but it's not here. And something that he was talking about the universe expanding, something that is fantastic in this history when we talk about the Big Bang and the model that you have, because we have things that we cannot explain in this model until today. And something that few people know about when they talk about cosmology. That it's the best model that we have, but we have many things in this model, and that we cannot explain. You cannot use the model to explain everything that we measure. And here is position of, I will show only this before I talk about this. Here is position of the sun in the Milky Way. Here is where we are. I'm showing the image of the galaxy because one of the problems that we have when we talk about the universe, our model of the universe, and what's happening in the galaxies, is the rotation of the galaxy, the velocity of the rotation of the galaxy. Here are the stars near us, in a 3D model. Here is Alpha Centauri, the triple system here. Proxima Centauri is near us. But I'd like to show this. This a fantastic image of a lot of galaxies, the deep field image taken by the Hubble telescope. And here you can see a lot of galaxies. And when we studied the movement, the rotation of the galaxy, that appeared one of the problems of our physics that we can't explain with the physics that we know. And as we don't want to change the physics, is the last option, we try to find a way to explain what we measure. Then we are now here. Here is the image trying to show our model, the best model that you have for the universe. Imagine that one moment you had all the universe in a small, very small, everything together in a very small place. A piece, very small piece, and we don't know what happens at this moment because we don't have physics to explain. It's a lot of energy, and the physics that we know can't explain what's happening. But as we now need to consider that the universe is expanding, then to begin the expansion, in one moment we have all the things that we imagine in a very small piece. And when I talk about this in the model that you have nothing there, almost this. Then when the universe begin to expand, we have to begin to have the lights, the area that dominated by the radiation. Then we have the first particles that appear, and now we found a few years ago it was possible to find the boson of Higgs that was what we need to explain the moment that the particles appear in the universe. Then we have the expansion of the universe, but I will not talk about this. I'm showing this because I only like to talk about two problems that we have, that they are not solved. One of them, one is associated with the expansion of the universe, and the other is this. This is the composition of the universe for us today. 23%, almost 23%, maybe it is composed by dark matter. 33%, 70%, 3% of the universe for the dark energy, and 4% of the free hydrogen and helium, and 1%, more or less, it is the matter, how we know that half of this we have in the stars. Heavy elements of the universe is very small part of the universe that you know. And for me, when I talk with the students here and we begin to talk about this model of the universe, two things that we have that we can't explain, and we have the dark matter and the dark energy is something that we need to consider as hypothesis to explain what you measure, and we don't have a model to explain. The first one problem is when we measure the velocity of the rotation of the galaxy. The prediction is this one that is calculated here according to our knowledge, according to physics. And then we have the estimation of the mass of the galaxy, the distribution of the mass that you have in the galaxy. And with this information, using the physics that we know, this red line here is how we imagine that is what is, we know that in the model, when we analyze the solar system, is what we imagine about the rotation of the galaxy. I have calculated this. But what we measure is this here in the white line. Then we can't explain what's happened, why we have a high velocity than it was calculated when we go to the far from the center of the galaxy. To explain this, we imagine that we don't know all the mass of the galaxy, well, because we need more mass in the border of the galaxy to explain what we measure. But as we don't know, we can't see, we don't see this mass, we consider that we have this mass there, but we can't see it. Then we call this mass as the dark matter. And but for science, we need to find what is the dark matter, and we didn't find. And as you see in the model, we have to consider the physics that we know. We need to find this dark matter in the galaxies, and this is responsible for 23% of the universe that we know. It's something that we don't know what is, and you don't know if it exists. It is, we consider only because we can't explain what's happening. We have two ways to solve this. One way is to change the physics that we know. But as this is the last option, we try to find what is this dark matter that we can't see and we imagine that can exist. The other thing that we consider also, because the universe is expanding faster than the predictions of the model nowadays. No? And to explain what's happening, we have two options also: to change the model, all the model, or to find something that is making the universe expanding faster now. Then the easiest way is to consider something that we don't know what is, but existing in the universe and is responsible to expand faster the universe. And we call this the dark matter. And as we have the universe moving faster, we need a lot of energy for this. Then we need to consider 73% of the universe. Maybe it is composed by this dark matter that we don't know what is. Then we have two problems that we don't know what is, and we have hypotheses and try to find what can be, but we didn't find until today. It's something that is fantastic for me, because sometimes here in Brazil we have this problem. I don't know if United States and other countries, because we begin to talk about the Big Bang with kids in school, and the teachers that talk about the Big Bang, they talk something that is the model that explains everything, but it's not a model that explains everything. We have many things that we don't explain with this model, like how that begins to form the galaxies in the universe, and these problems that I showed now. And I think that this is something that is good for the future, because the young astronomers will have work for a long time until to find a solution for this problem. And it is like we have here a fly. I don't know how to say in English. That's a fly. We call here a fly of banana. That is a small fly that lives only 24 hours, approximately. And we are like this fly, because we live, we have maybe 100 years, at maximum 100 years, something like this. And we try to imagine the universe that have almost 400 billion years. What's happened in the past, and what can happen in the future. Then it's the same thing of this fly, because they live on 24 hours, how that they can know that a kid one day will be an adult that he see. That is the same thing that's happening with us, trying to explain the universe. Then this is a topic that's, for me, is something that is fantastic. Even in these hard moments that we are living, after the COVID, you have a war. It's something that is very sad, very sad, but something that we can think, and you know that we are very small in this universe. Then you don't have, you live so it's so fast, the time that you are here in the earth, that it's not possible to imagine if when we use the reason to have fights like you have the wars. And here our project, the Young Stars of Tomorrow, have here the support, and here are the last activity that we did in schools. Here are the team. Today here is International Day of the Women, and in our team we have 8 girls that work with us. These are 3 of these girls, a Caroline that produce cartoons, Isabelle that she's doing apps for Android, and here is Stephanie that she studies in fundamental school, and she's working development of apps also. And the participation of the students in our public schools here in Brazil, near us. 2 students that did the best work, we give prizes to them. Have a NASA sticks, there is some prize to give to the students. And the other students receive also solar glass that sent to Stephen Rams, then sent to us. And this is the activity that we return this week. We are planning until the end of the October, we will be probably we will develop activities in more than 50 schools. We already developed these activities in 23 schools here in our city, and we think that in our plans probably we will develop activities in more 30 or 40 schools. Then until the end of October, we have more than 50 schools that we develop the works. And we are now organizing the international meeting that will happen in 22 and April 22, 23. And soon we have a new edition of the Skies Up magazine. Thank you, Scott, for the invitation.
Thank you, Marcelo. I will never tire of seeing that magazine cover for some odd reason.
Right. That's right. It's a great shot, Adrian. A couple of comments or questions as well. Harold Locke says the implications of so much dark matter in energy would suggest that before the other heavy elements and gases, that there was only dark matter and dark energy. Is that the current thinking?
No, no, because they are, when you talk about dark matter, we imagine that something like a interaction, a force between the matter that make the matter now I forgot the word in English now, but it's different from the gravity that makes the mass come together. This is something that make it be apart, né? Go. Then is something, some kind of energy or a force that will be in all the universe, né? And but it's a model that nobody knows what can do this. Something like anti-gravity, something like this, but we don't have this. We don't have negative mass of a particle.
Right.
Then the interaction of gravity only bring things together. Then it's something that we don't know what is. But we know that the universe expands faster than the prediction we have in the model. Then we need to consider something to explain this. And the dark matter is something different from this, because dark matter is something that we imagine that we have in the border of the galaxy that is affecting the rotation of the galaxy to be according to what we measure. That's not what we calculate from the idea that you have of the mass of the galaxy and distribution of this mass in the galaxy. And then if you use the physics that we know, we can calculate the rotation of the galaxy if you have information about the mass of the galaxy. Then with this information, the calculus, the result of this calculus, it's not according to the measures, the data from the data that we have about the rotation of the galaxy. Then, as we know, the only thing that we know that can affect is the gravity. Then we imagine that is some kind of mass there in the border of the galaxy that you can't see. Then these are different from the dark matter, the dark energy. Dark energy is something that you have in all the universe that is making the universe expanding faster. This is called dark energy. It's something like anti-gravity or something like this, but you don't know what is.
They don't know
things
what it
that are different. One is something that's affecting the border of the galaxy, and as the only thing that we know that can affect, because we have 4 forces, for interactions, that you have the electromagnetic, the nuclear strong, and the weak, that is inside the atom, the nucleus of the atom. We have the electromagnetic force, and you have the gravitational force. When you talk about the border of the galaxy, you have only what can change this is a big mass, a lot of mass, and we need to consider the gravitational force. Then we need to, as you can see, we don't know what is, but we imagine that is something that has mass. Is what we are looking for. These are things that are different.
So,
I don't know if I
energy,
answered the question.
yes.
Like
it makes more questions. So there was someone else on it looks like Twitter that is asking, why aren't the galaxies slowing down? Doesn't gravity drag help slow down the expansion rate? But this,
No.
question of,
What's happening is not this. What's happening is not this. The prediction is that we have low velocities in the border of the galaxy. This is the prediction. This is what the physics explains.
Okay.
It is not this that it is measured. I can show here again. I don't know if this is doubts. What they measure is that the velocity is like the same. Here, let me try to return here. This one. This is the observation.
Okay.
This is what expected.
Very different.
Yes, this is something that is measured, we observe, and here is calculate what is calculated. You see that in the border of the galaxy, the velocity is low. Then you have here, and what we measure is that is like the same or something that is bigger here. Then we can't explain this with the mass that we see. This and the physics can't explain. And we have two ways. One, you can change the physics, the model that you use. But this is last option. We try the easiest option. Saying that is something that we can't see. We need to find something that can explain this behavior of the galaxy, but it's something that we don't see, but it exists. This is the easiest option that we're trying to find, but we didn't find it until today. Is this what you asked?
All right. Well, thank you very much.
I answered correct?
I think so. I think so. Okay. Well, thank you, Marcelo. This fascinating, and I have many more questions myself, but I don't think we have time. But we look forward to the next issue of Skies Up magazine. I look forward to your program for youth and their activities. And we have a telescope here at Explore Scientific that's waiting for your students to use. So
wow, great.
Okay,
They asked me about this. Great, fantastic.
Yes.
Okay.
All right. Thank you, Marcelo. Thank you so much.
Thank you very much for the invitation.
Thank you. Thanks. Okay. So next up here is Adrian Bradley. We love Nightscape images. Adrian's shown us many views of where his neck of the woods is up there in Michigan, and but he showed us some beautiful shots that he's done also in Oklahoma, and we know that he wants to get around and explore more of the night sky around us. So Adrian, thanks for coming on to Global Star Party. We are running, we've run a little bit behind. I'm sorry for that. But
it's okay. I'll try and make my presentation quick.
Okay.
I gathered a bunch of images. Let me just go right into it. I'll share the screen where all the images are. And I built kind of a little bit of an outline so that I could show, so I could rifle through pretty quickly. So what I'm doing now, you're seeing some imaging that I did of the Orion area. I'm going to go over, I decided later I'll go over kind of the difference in what you see in the night sky, depending on where you are. This is a Bortle 4 site. And if you compare that to, this was with a non-mounted camera. And I'll talk about that later on. So let's see. I've attempted to do some imaging. It's the same night and these clouds moved in. So the clouds can create that halo effect, that same effect that a filter can create. And this was the last shot I took before I gave up. For those of you in the Southern Hemisphere, you can see starlight still makes its way through depending on where the clouds are. This lets you know that these are medium to higher clouds, whereas the lower clouds tend to block more light. And this is in the north. UK calls it the plow. America, we call it the Big Dipper, and this would be the Little Dipper, and this is our North Star right here. That's my truck, and that's an Explorer Scientific rig. I'm actually trying to do some classic wide field. So how did that turn out? It turned out kind of like this, with the Orion Nebula, the Running Man NGC 1977. Because it was hazy, I got this haze around the stars, but I also got some detail as well. There's the horse head, there's the flame. So a rough draft, there's Barnard's Loop. So a rough image with 6 minutes, had it been a little clearer, a little bit better, I think my data might have turned out. So other thing that I like to share about the moon, this is just a quick image taken handheld with a 600 millimeter lens at the growing crescent moon this past Saturday. Sadly, we won't be able to do this. This was taken 20 minutes after the lunar X and V terminator was in perfect position.
Mm-hmm.
There's the lunar X, there is the lunar V during a daytime moon last month in February. So whenever the lunar X and V are visible, and if you take the image at the right time, you can see those two features. They are, the X is created by surrounding craters in the way that the terminator hits them. The lunar V, there's a rim here. It looks like a V, it looks like an X. Mm-hmm. And so for those that go after the moon, it can be interesting. Jumping ahead to May 15th and 16th is when we're going to see a total. This wasn't quite total, as you recall, but it will be total in the Americas. North America gets to see this. However, I am going to be on the West Coast. This is going to be above the Milky Way, so I'm rather torn apart by how that's going to work. I'll briefly show. Here's the Milky Way as it's going to look. The moon, the eclipse moon's going to be up here somewhere. So those of you that can get the shot definitely want to mark down this total lunar eclipse, because the galactic core will come with it. So speaking of the galactic core, I attempted to capture it at daybreak. I'll show you. This was a picture that I took from a spot overlooking the Huron River last
beautiful.
year.
Yeah,
I had a lot of the galactic core, and this was, you notice the color of the sky around it. And then later I took some pictures, and you notice the color of the sky started to change, because at the moment of daybreak, the bluish light from the sun's light beginning to scatter out in the atmosphere jumps into your photo, and you get around a 5-minute period where all the stars in the sky and the Milky Way itself are visible, but you have a different color of night sky. This is actually the moon rising, light coming from the moon that's peeking behind the clouds at the time that I took this. So I tried it again, and I was met with cloud cover. Would have been, in my estimation, a beautiful picture. This was at the moment of astronomical twilight. I took a couple of other photos, And as you can see, I still have the North American Nebula here. We still have the Cygnus region, and there's Cassiopeia, a couple of meteors that photobombed the shot. And this is the glow coming from towns, but as astronomical twilight continues by the minute, and you'll see with this, I took a longer exposure image, but you can see it's beginning to disappear the brighter it gets. So that's always an interesting time, more meteors that show up. It's an interesting time to image. Francois mentioning, excuse me, about how clouds can beautify a landscape image. I went ahead and shot anyways. Here's an older view of the same thing from last year. You can see the Milky Way beginning to be washed out by the presence of the astronomical twilight. And you can kind of see a shape of the moon here too. The fact that it's coming up as a crescent. So before and after shots. We talked a lot about a Portal 1 site and what it's like, and I will share with you really quickly on some of these images. Before I do, this aurora happened during the spring equinox, and the spring equinox is coming back. So there's usually a good chance of auroral activity during the spring equinox. We've had an active sun, so auroral activity could be going on for quite some time. So let's talk about what really quickly. Let's see, a Portal 1 site looks like. So compare it to, say, Portal 2. These are a couple of good pictures. This is a naked eye representation of a Portal 2 site and what the Milky Way looks like in a Portal 2 site. You can see the detail that you're seeing in this picture. Your own eye roughly sees this same detail. Since this is taken with a wide angle lens, your view is more like this. And that's what you're seeing naked eye. When you process something like this with a camera, all of that detail appears. This nebula here, the coat hanger shows up. There's Rho-Ophiuchi, the Rho-Ophiuchi complex over here.
Oh, yeah.
And all of that shows up when you take it an image. That's Portal 2. When we go down to Portal 3, we can still get a pretty good Milky Way, but we don't quite get the detail. And of course, my processing here wasn't quite the same. So like the Barnard's E is right here. The coat hanger shows up here. Those are some of the things that I look for in a detailed Milky Way shot.
You've learned a lot about the sky by doing these kinds of shots.
Yes, absolutely. So now quickly, here's Portal 4. So if you notice what you're seeing here, same sort of things are there in the sky. The coat hangers around here somewhere, I believe. Actually not seeing it. Not usually, oh, there it goes. There's coat hanger. There's Barnard E. Those are the stars, Tarzed, that is Altair. And this was back when Jupiter and Saturn were close. But notice about what you're seeing with the Milky Way here. And that was 30 seconds. Here's a Portal 1 sky, and that's 8 seconds. Notice, now this is with a 50 millimeter lens, but notice about the coloration and the detail that you get in 8 seconds at a Portal 1 site. Say there's clouds. Notice how the Milky Way shines through those clouds. You look up and you see a glow And when you take the image, you'll recognize there's the lagoon right there. There's a Sagittarius star cloud. It is bright enough, and these are a couple of stars. That's Nunki, I believe. A couple of stars of Sagittarius. It is bright enough for the Milky Way to show its light through the clouds like the full moon does in the lesser zones. And if you go for 30 seconds at a Bortle 1 site, you get this much detail. In fact, the processing here makes it look a little crunchy, but all of this entire part of the galactic arm and core, easily visible. M16 and M17, I believe. This is something different here. There's actually some nebulosity here that's in Ophiuchus that's beginning to show up. It isn't just an artifact. There is some. This is an HA emission right over here. So if you don't have a modified camera, a lot of those were shot with modified cameras. Say you don't have a modified camera. Well, let's look at the difference. Here's a Bortle 1 Milky Way with a modified camera and then edited to show more natural lighting. And notice the grayish blue here. Then I took an unmodified camera, essentially took the same type of shot, and we didn't lose very much. A lot of satellites and things streaking through the sky, which is unfortunate.
The Milky Way light reflecting off the cars.
Yeah.
That's amazing.
Milky Way and starlight.
Yeah.
Reflecting. It's that's how dark it is at a Bortle 1 site. So that tells you this was 30 seconds and a lot of heavy processing to pull this Milky Way out. This was 30 seconds, a couple of routines in Photoshop. That's without the hydrogen alpha edit. This is with the hydrogen alpha edit. So you see a little more the reddish. That's why the red is coming out more down here, because the camera is more sensitive to the hydrogen alpha or the spectrum of light that is in the red. It's often called infrared by other photographers. So this is again Bortle 3 and was not shot with a modified camera. Shooting at Orion with a modified camera results in images like you get to see the rosette and things of that nature. So let's see, that is one of my goals. This was taken maybe a month ago, looking over the El Sabo River. This is south by southeast. So you can imagine if you take Milky Way photography, this is now happening at, which will soon be 4 in the morning. The Milky Way is going this way, the galactic core. So that's the next picture that I would like to acquire. That and a good galactic core daybreak shot, because this one was sort of washed out. So the attempt was to kill 2 birds with 1 stone. I don't know if I'll make it, but that was going to be my goal for my next image that I was going to try and capture. And then finally, because I know you love the bird, Scott,
yes,
I'll share, when it's cloudy outside, you have to find the great horned owl, which this is a tough shot actually, because
that's the other stuff in the universe.
Yep, there other things that make up the universe, like
beautiful
eagles flying when it's really dark, and you can still get as good a picture as you can. And then you've got the seagulls.
Oh wow, that's a good one.
Yeah, show that one again. Sandhill cranes landing.
Wonderful.
And finally, I thought I had another one for you, Scott, but you practice your
oh, that's beautiful. That is really nice.
Yep. Similar
Excellent.
camera that took that shot also took this shot. So use the gear that you have. And actually I may have mentioned the zodiacal light is back.
Yeah.
And this is the exact same camera that took those bird shots. Took this zodiacal light shot right here.
And the exact same photographer.
The exact same photographer, just a little different technique to get those, and definitely different lenses. So that's where I will stop my presentation. Thank you all for looking at the images and following along. So there's plenty to look at in the next couple of months. A lot of Milky Way shooters call it Milky Way season when the core of the Milky Way is visible. For me, Milky Way season is year round. Depending on how dark a sky you go to, you can still see the band of light coming from the Milky Way, even if it's deep into winter in the northern hemisphere or southern hemisphere. You all get to see the Milky Way rise high overhead as winter is coming your way. And that's usually when the astronomers in the southern hemisphere that brave the cold often give us beautiful shots of the core of the galaxy high above high up in the night sky. And so with that, I'll end. If there's any questions.
It's just, you're an inspiration, Adrian. It's wonderful to see your Milky Way shots, but I love to see the birding shots too, especially that one of the geese flying. That was incredible composition, and your sense of capturing things is very keen. So
I
thank you.
appreciate it.
Privileged
That
to
was
have you
kind of
on.
the geese are moving. Let me go take some photos shot. So I was very happy that turned out.
It turned out very well.
Yeah.
Thank you so much.
You're welcome.
Okay, well, up next is Maxi from Argentina. He's been waiting very patiently there here on Global Star Party. Maxi, what do you think of the Global Star Party so far?
It's amazing Star Party. I'm talking a little louder because my wife is sleeping right now, but
okay.
We'll try not to be too loud.
I'll speak more quiet. Yeah, there we go.
Yeah.
It is
Okay.
International Women's Day, so she can sleep.
Yes, she deserve it. So, well, thank you again for inviting me. Hi, Adrian, Marcelo, John, Scott, Francois, and everybody. And I want to talk about this past 2 weeks that we've been in the last GSP. Well, I've been the last GSP. And first of all, last week we did a local star party with a couple of friends in Alberti because we had holidays of Carnival, and we have 2 days to celebrate or do anything, and that weekend it was raining, but the other 2 days was go okay. So we decided to get meet, and well, first of all, let me share my screen. Okay. Well, the last GSP I couldn't be here. I think it was the 23rd of February, or the 22nd of February, but the 23rd I practiced with my gear using only a UHC filter in Bortle 5 skies, taking pictures of M42 and Eta Carinae. And this was the results. You know, practically it's a lot of information that it takes inside of the nebula, and I have this kind of reflections of that filter, but you know, there's anything of contamination or that I had to take anything. There's nothing almost, and also the 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 the, the shapes of the nebula and the gas. You know, this place I really love the of this nebula, and also I did this in the Eta Carinae nebula, pointing to the south. I think in this case I went a lot in colors, but you can see this place really these structures that are jumping inside of these clouds. It's amazing. You can this place. I really love to watch it. Also in this in the core of
All
the
those little
nebula.
star forming areas there.
There's a lot. It looks like the lava lamps, you know, the inside of the lava lamps.
Yeah, the lava lamp, sure.
So then I did some pictures of the moon, and this is what I get without that filter. This is only because I say, okay, let's take a picture with scope and stack it. So there's a lot of details, and because I love to take pictures of the moon in this kind of the way, because you have minerally, but also you have the craters and the shadows that gives you contrast, and I really love to take pictures like this. So the days passing by, and the another week we see that Sunday, it was the Sunday 27, and this is almost midday, but you can see it's a lot of cloud, but to the south it started to open. So we decide to get meeting. We start to travel to Alberti. You can see this is the really plain, the field. There's no mountains in a lot of kilometers, and but we have this these clouds lower, but up above there's almost no clouds. This is the dusty road heading to the observatory, but it was okay that in the road, because that Monday and the last day it has rainy, but the road dries and we can get, but almost when we get there we have a little trouble because the road, it wasn't really good. There's a lot of mud, but let me take you still continue. Here's our cars, and you can see like a
dirty.
yeah, and this is nothing compared you're going to see in a couple of minutes. This is my car. It's like chocolate everywhere.
Oh my gosh.
I felt like it was in a Rally Dakar or something like that. And but we can get there. Well, this is a selfie of me. Well, this is Leonardo Yasutake. He came from another group that he wants to go to a farm area, and of course we invite him. So we been the first one to get here. A couple of minutes of these pictures, they came another two people, and then more later, Nico the Hammer. But he couldn't get there because when he calls me, I say, oh no, he gets stuck in where I get
Oh,
the
no.
small. So we are four and we have some kind of tools. I have a cable to attach the car to something, but we are walking because it was really dark at that time, and this light is the car of Nico, and this is the truck of the neighbor that was passing by when the four of us was walking in this mud road and in the dark with our flashlights in our heads and a lot of bugs in you can't breathe. But he said, let me help you, gets up in the truck. So we head up to help Nico. You can see the mud in the place. You have here Nico. This is me putting that cable to attach it to the back of the truck, and then we pray to to both don't go to the border because it was filled of water. Then they start to pull Nico more back so he can put in more safely ground, and then start to came more safely in the road. This is behind where Nico was stuck in. You can see here's a lot of water in the other side.
Yeah.
And this is how the
Oh, wow.
no, it was amazing. You know, and this is only maybe 700 meters from, maybe less, 500 meters from where we in the observatory. He was almost there.
Oh, no.
So well, he can came. We start to get jokes and laughings and and everything. So well, then we take some matters and start to grab our equipments. So this is a picture taken more later from Sebastián Jeremías. He's one of our friends that came. You can see the royal school. We are in the back, and in this case, the Milky Way is starting to rising up. This is the east, the south, and you can see the large Magellanic Cloud. The smaller is behind in this case, and you can see it's starting to get fog because there was a lot of humidity. But
The Milky Way coming up. That's beautiful.
this is a beautiful shot, and the cables gets you some kind of reality, you know, because sometimes you say, "Oh, this is the perfect big picture," but the cables give you that this is in a real place. So this is another one picture. Here's me with my equipment. Here's the Nico sitting and watching. This is the scope of Leonardo Yasutake. It was 40 inches telescope. It was a huge telescope. And well, this is an 8 inches f5. This is 6 inches, I think. And well, you can see this is the light pollution of Alberti. This another one is from Bragado, the next city, and behind here is Chivilcoy. They doesn't bother too much to us. This is another picture from Diego Gentili. This is an amazing picture of the, well, this is the light pollution of Chivilcoy, but the rising up of the Milky Way is amazing. You know, watching this going up, that's amazing. So there's another picture of Sebastián Jeremías. This is in front of the.
Cool.
You can see the two
Large
Magellanic
and small
clouds,
Magellanic clouds, yeah.
and
Look at
also
that. You can also see the rotation around the South Pole. It's beautiful.
yes, and we don't have a polar star.
Well, there is, but it's faint.
When you get to get polar alignment, it's kind of lottery if you find the stars that help you to get a really good polar alignment.
Yeah, I thought Octans or something was the closest star to the
Yeah.
area where it's spinning around. So
There are in octans. There are 4 stars that you have to get in a pattern to get pointed to the southern polar axis. So
yeah, so a little more complicated than it is for us.
you have one single star and it's really brightening. When you are in urban skies, it's kind of, you can find the octans. But when you are in rural skies, you have a lot of stars to find that 4 single stars in the middle of a lot of
Right.
stars. So, well, this is I really love this picture because it has a lot of contrast, of course, of the structure of the school, and well, the grass, the background, sky, and so well, this is the next Monday. Yes, the another day, we was taking a little of breakfast and lunch time with, of course, mates, biscuits or galletitas or masitas that we call here. Here's me, here's Leo Yasutake, Dio Gentili, Nico de Hammer, and this is Seba Jeremías, the author of these pictures.
That's great.
And well, this is another selfie of me. We have a lot of humidity that night, and you can see it in the fog, but you know, it was only in 1 hour. Then the fog went out, but the grass was really wet, really, really wet. And you can see some clothes of mine drying with the sunlight because there was really not too much cold, but really, really wet. And the wind that morning, it was blowing from the south, so the sky is kind really blue because they dry everything. Well, the sun starts and goes down. Here's me preparing my equipment. Nico, well, you can see the 40 inches telescope besides
Right.
Nico. This piece of telescope, you know, it has go-to and motor sided mounted, and when he puts oculars getting zoom, you when I saw the ghost of Jupiter nebula, you can see the shape and the center of the star, like it was a big eye watching you. And when I saw the antenna galaxies, you can see the core of that crush galaxies. Now it was really a huge, amazing telescope, and he was searching quasars. he has a list of 10 almost, but he could find only one in 2 nights. Well, this is a picture of Dio Gentili that took off my gear, contrasting with the sun. And here's the Nico de Hammer telescope, the 12 inches, and besides of Leo 40 inches. And this night, you know, when the neighbor of the farm of the observatory helped us to get grateful, we want to get him money, but he said no, that doesn't problem, don't worry, it's okay. We decide to invite him and his family to, if they are interesting, to see what we're doing, because this is an open place. This wasn't only for us. Everyone's could be here, but it doesn't have the the commodities or for staying too much time maybe. But that night they came with 2 cars, and they bring uh, their sons and their childs with them to see the skies, and we did some kind of tour showing them through these 2 scopes, but also doing astrophotos in real time, so they can see what we are taking or watching. And it was an hour like I felt, and everybody felt like a professor's teaching. And you know, it was amazing because they were listening to us, and they were um, um, comprehending that we were saying. So then they goes away, and we continue to start taking pictures. Well, this is another picture in the full area of all the scopes that we have. And you can see there's bottles of wine, mates, thermos, everything. And well, this is a that night it came also Ariel Rodriguez. Is a friend of us that we say him that not come the last night because the road it wasn't really good to drive it at night. So he came the another day, and he did this picture of the front of the school. You can see the pigeons sleeping.
Oh yeah, there are all the birds up there.
and also the Large Magellanic Cloud, Canopus, and Syria stars. And this is well, he's the brand of him, Astrooptica. And here's another picture that he took of everyone else. Or here's me watching my cell phone because I was controlling everything from there. This is Diego Gentili. Here's Seba Jeremias watching the sky. This is Leo Yasutake. He has this bench to get set because when the telescope goes up, it's really difficult to still watching without move. So this is a really good tool to watch. And beside him, it was Nico that was also observing and doing his drawings. But you can see this is the sky looking to the west. You can see this is Orion going down, the sword of Orion, and this is Sirio star. well, this is a picture of Nico that was taken also from Ariel Rodriguez. He asked him to take these pictures to him, and they're watching the Large Magellanic Cloud with his scope. You can see the it was really wet, but not that like the last night. And this is a beautiful picture, amazing picture. And well, this is some kind of what I get from my own stuff. This is the heart of the Rosetta Nebula. This is an open cluster stars, and also the nebulosity is that surrounded. It's almost 2 hours of 2 nights stacking, and this is in urban skies without filters is almost impossible, but in this case it's amazing. Also, one of my goals was the triplet of Leo, and this is what I get all also 2 nights taking pictures to there. You can see there's a lot of stars, galaxies, but the shape of the galaxies, I never could get this kind of forms. And this is the Hamburg galaxy, and also you have here another one's galaxy that are really far away. And also I did the
Oh, that's beautiful.
sorry.
Yeah, I love that.
Yeah, I really
There's
love
NGC, what, 3628 over there? And
M6, M65 and
66.
Mhm.
Yeah.
And then I did the Sombrero Galaxy M104. This is only a half hour of taking pictures, but it's amazing the shape of the galaxy that I could get. I never could get this donut besides the galaxy, and the different contrast in the nebulosity in the galaxy. Now this is an amazing picture. That the most I could get. And also these 3 stars or 4.
Oh, yeah. Look, there's a little galaxy down below.
Yeah, there are 2.
There. Yeah, 2 of them. That's right.
And also there are too many more. I compare, of course, with the Hubble picture, but it doesn't have comparison. And also, I don't remember the another one picture. Oh, the Needle Galaxy. This is kind of some kind the sombrero.
891, NGC 891.
NGC.
I think it's the spindle.
4565.
Yeah, 4565. I think it's a spindle.
Yeah, the Needle Galaxy. I know this. I don't know if you, well, the catalog of Stellarium says that. But also you can see here there's a lot of galaxies.
Yeah, that is 4565. It's also called the needle.
The needle, yeah.
Mm-hmm.
Yeah, I got it wrong. It's not the spindle galaxy, it's the needle.
And here's another.
And look at that one. That's cool.
Mm-hmm.
Yeah.
And here's two.
Yeah.
Now this place is huge of galaxies. I really love this place. There are not only stars, there are galaxies here. And also in this place, there are too many galaxies. This is unbelievable. So
yeah, I think some imagers call it galaxy image season because Leo and Virgo come in and so many super clusters are in the line of sight of those 2 constellations.
Yeah, exactly. And also I did some pictures from another objects that I didn't process them, No, sorry. This. This also here. This is a single picture of 3 minutes. There are some spiral galaxies and lenticular galaxies. Also, no, this wasn't. I think it was this. Well, the Centaurus A galaxy. I think the last one. Yeah, here. This is only a single shot of 3 minutes. I didn't process this because I had some troubles with the focus, and then when I get focus, I say now let's go to another one, and say that's it. But you can see this a lenticular galaxy, but also I could get this place that in urban sky is almost impossible, you know, and the color of the galaxy is amazing.
Yeah.
And also, well, I did M100. I think, I don't know if this is stretched. Yes, some kind of stretch. Let me open it in PixInsight, because the single light here. This is M100, and also there are too many galaxies here. This is a really spiral galaxy, but it was some kind below, and I have some reflection that from a LED light that ruined my subs pictures. But this is a really good place to take pictures of galaxies, and I really love this was Dio Gentili's idea to take pictures in this place.
Yeah.
I don't know. Well, I also did some pictures of the moon because it was coming up in the east. You know, look at Venus. It was really amazing. But watching this, I did some pictures taking with
Very
different.
nice with the earth shine.
Yeah.
Yeah, this is the most beautiful. You can see there's a star, but this is not processed. This is only stacked. But I really try to do some. I tried to do some stacking, but I couldn't get nothing for now. So I don't know if I had another. This I show them. I think this the last one that yeah. I try to do pictures of this place, and you know, this is kind of antenna nebula, I think, but I think these galaxies are this one is in the background of this one. They are not touching, I think, but you can see here there's also a lot of galaxies floating in the dark matter of the universe that was talking Marcelo's a couple minutes ago. And well, I think, I don't know if I get the stretched. and it was this. Process, strength. Oh, wait, no, este no. Ahí. This is an auto stretched. You can see the lines of the satellites passing by, but I think in this place the focus and the guiding and everything was really fine. You can see the stars are really rounded, the spikes are really good, the
Yeah.
details of the galaxies, they are really good, but only I did, I think, I have an hour only, but it was some kind of practicing, see the field of view with the camera and the scope in these places to get more data in the future, and still learning about this. So, well, thank you again for inviting me. This is
You,
my
Maxi, thank you. It
sorry
was
if
great
it was
to
a little longer, but I
No,
hope
that's
it's
No,
fine.
that
That's fine.
was
I
very
know that you
informative.
have a lot to show, and so it was impressive. And we always love your images, Maxi. I love your astronomy stories, especially. So because it's you're
I like
bringing us
to
to your star parties with us.
yeah,
know.
I try to do some kind of that because I love to talk. I love to talk too much. And well, my wife and my friend says, Maxi, get shortly. Come on. No, I can't. I can't. So also my brother, Dale, Maxi, come on.
Come on.
But well, I think I was born to get to or to write books of stories of some kind of that, but I love astronomy for now.
It was very cool. Thank you so much, Maxi. All
Thank you.
right. Well, that's great. Well, I think that we are at the point where we will wrap up this global star party. I have a little video to show about James Webb and some of the people involved with the James Webb Space Telescope. I know
Yes.
that we're all waiting to see some high resolution images from James Webb, and I'm most certain that we're going to see those. But they're still calibrating, they're taking their time, and as well they should. It's been
I had to calibrate my scope for 1 year. And this is an 8 inches. I can't believe they're only in a few months.
In a few months, they're going to be ready.
That size.
Yeah.
No.
So
Yeah.
I would like to make a public service announcement. Beware that YouTube artists are at it again. I marked a few images or a few videos on YouTube as misleading, where they're saying images from James Webb Space Telescope. Yeah, there's a few folks that are pushing some, or pushing out that that their images already captured from the James Webb Space Telescope, and they appear to be images that are captured from other space telescopes like Hubble. So just beware, there are no official images. There's the one star that I think they calibrated the 18 mirrors, and so now they have a single star that they picked. I think that's the only real image that James Webb has created as of yet, but it's got more to go. Like we mentioned, the calibrating of the mirrors. So yeah, I think there'll be an official outlet of images from the James Webb Space Telescope when it starts doing its thing, and so we look forward to that. So just
Yeah.
a public service announcement for those that are still with us at Eastern time. It's 15 minutes till midnight. And
Yep.
certainly past my bedtime.
All
So
right,
I
Adrian.
am going to
2 a.m.
yeah, it's 2 a.m. for you, Maxi. So well,
Only 10:44 here, so it's good.
you've got time to party, Scott. Party's just getting started.
That's right. That's right.
So,
All right. Well, thanks, guys. Thank you so much, Adrian, Maxi. Thank you so much, and we will be back next Tuesday with another Global Star Party number 86. So, all right.
Great. All righty. Thank you, Scott.
Thanks.
And hope to see you next week. I've got some presentations coming up, so
Okay.
I'll let you know if I'm able to make it.
All right. All right. Good
All
luck,
right.
and good luck on your trip to the West Coast.
Thank you.
Bye-bye, Adrian.
Okay, guys. Bye.
Good night. Good night, Maxi. Take
Good
care, man.
night.
Okay, we are going to run a little video, as I mentioned, about some of the people that are operating the James Webb Space Telescope. I thought this would be interesting to you.
Most of us can picture a telescope, typically a long tube mounted on a tripod. Telescopes come in all shapes and sizes, and they're some of the most powerful machines in the world and in space. But how do they work? I'm Leilan from ESA Education, and today we're asking an ESA expert working on the James Webb Space Telescope. Welcome
Thank
to our
you.
little studio.
Thank you very much.
Dr. Giovanna Giardino, thank you for being with us today.
Thank you. Thank you for the opportunity. I'm very excited.
So what do you do at ESA?
So I'm an astronomer and I work for ESA on the Webb Space Telescope.
I think a lot of people envision a telescope like my childhood telescope.
Yes.
So it's sort of this tube.
Yes.
And even the Hubble Space Telescope is what everyone pictures as a telescope, this kind of giant tube in space.
Yes.
How does a telescope work?
So in very simple words, a telescope, it's a bit of a bucket of light, bucket of photons. So using a lens of a mirror that is inside this tube, you collect the photons, the light from an object and concentrate it, focus it in a specific point so that you have much more signal, much more light for that object that you would have with your naked eyes. And that way you can see far away objects, weak signals.
But then you have the James Webb Space Telescope that looks completely different, and yet it's still a telescope.
Sure.
Why does it have such a unique design?
The main elements of a telescope are really the mirrors or the lens that you use to collect the lights and focus it, right? So that's what you have to have. The tube is that we see in many telescopes that we use on the Earth as mainly two functions. One is the holding of the lenses, the lenses that you need, or the mirrors. So you have to have a structure that keeps them in the place and with the right distance from each other. That's very important for focusing. Going for the tube allows you to block off extra light from the surrounding that you don't want to come into the lenses and disturb the clear vision that you have on the sky. It also keeps it clean, right? In the environment every day, there is dust and things, so the tube keeps it clean.
So the fact that James Webb Space Telescope doesn't have this giant tube, how is its structure being held together? How is it remaining clean?
Right. So the structure is held together. So by the primary mirror is mounted on the spacecraft, and then there is, if you notice, a tripod going off from the primary mirror to what we call the secondary mirror, right? And the lights gets into the primary mirror, the big bucket that I call, right? Get focused on the secondary mirror, and then focused again into the primary focus of the telescope where the instruments are, and we actually collect the lights and look at it in a camera or a spectrograph. So the camera, it's really a camera. So like the name says, we record images. So the telescope collects the light, focuses, and this camera collects it and records. So we see images, we can see the stars, nebulas, and the spectrograph the light entering a spectrograph is dispersed with a prism, or we also use gratings, but the principle is the same. The idea is to disperse the light and look at the components of the light. So like when you have invisible light and you shine it to a prism, you see the colors coming through. That's the spectra of the light. These are the components of the white light, the red, blue, yellow, that's the component. And the same we can do in the near infrared and in the infrared, and we look at the components. And why do we do that?
Good question.
Yeah, because in a way, the light that an object emits, it's a bit the signature of the object. It tells us a lot of what the object is made of, which elements are present, what temperature, what the pressure, what the physical condition.
And then what about the famed honeycomb mirrors? Why is it a honeycomb? What's the structure?
Right. So as you know, the Webb Space Telescope is one of the largest telescope ever launched. It's a 6.5 meter in diameter, the primary mirror. Even the primary mirror would not fit in any of the fairing of existing launchers. The diameter is about 3 meters. So the design has to be such that it could be folded for the launch to be fit into the rocket.
And I suppose the honeycomb structure is what really allows you to be able to fulfill that.
Right, the honeycomb, so that you want a continuous surface, right? You don't want gaps. So the hexagonal, as the bees have discovered, it's a very efficient way to tile a surface and also give it a rounded shape. You could do that with squares, but then you end up with a square telescope, which is not ideal to focus the light.
So the honeycomb mirrors are not just in the honeycomb shape, but they're also this beautiful yellow gold color. What material are they made out of?
Each of them is covered by a very thin layer of gold.
And why gold?
Why gold? Because gold is the ideal reflector in the infrared. So for infrared, for a normal visible light, we often use silver or aluminum, right? It reflects very well in your mirror. Mm-hmm. But in the infrared light, gold performs better.
Okay. And that's sort of this
that's
outer
the surface.
Layer.
The technology behind each of these hexagonal segment was developed especially for the Webb Space Telescope to make a large mirror that is light. So the material of beryllium was selected to make the structure that you see under the gold coating. And beryllium is a very strong, very stiff. It's got good properties when you cool it down, it's stable, but at the same time is a light material. So we could make a large telescope that is not too heavy and can be launched in space.
So you mentioned earlier a sun shield.
Yes.
Can we talk about the sort of structure of the sun shield as well and its purpose?
Yeah, the sun shield is very crucial on this mission. It was very challenging to design such a huge sun shield, 5 layers of special material as big as a tennis court. So obviously will not fit in any of their existing rocket. Mm-hmm. So it was designed to be in a compact configuration and folded around the primary mirror at launch, so that it could fit in the fairing of the Ariane 5 rocket. And the reason is there, it's because the Webb Space Telescope, it's optimized for observation in the near infrared, in the near the mid-infrared part of the electromagnetic spectrum.
That's the light that we can't see with our eyes.
Exactly. And that's the reason of the sun shield, to keep the telescope and the instruments, the scientific instruments, always in the shade of the sun and the earth. The space is very cold. It's minus 270 degrees. So by keeping the telescope always in the shade of the sun, we can cool it down to very low temperature, minus 220, 230 degrees Celsius, really cold. And that it's great to observe infrared light, because then we have a very sensitive instrument.
And how many detectors are on James Webb?
So there are 4 scientific instruments with different function for different type of science that you can do. NIRSPEC, the near-infrared spectrograph, MIRI, the mid-infrared instrument, NIRCam, the near-infrared camera, and MIRIS, imager and spectrograph.
Okay. And what are you hoping that information will tell us about distant galaxies, just the early stars?
We see objects that are 13 billion light years away from us. We expect to detect these. So it means that we're going to see objects as they were 13 billion years ago. So these are the very young galaxies. We want to know what was going on there. What was temperature? What was the pressure? How many stars? And we can do that with a spectrograph, exactly analyzing light. And then learn how the galaxy formed by looking at these very young galaxies.
Yeah.
If we come closer to home, we can also look, for instance, at the atmospheres of planets in our solar system, Jupiter, Saturn. You know, again with a spectrograph, learn what's going on this.
And Webb
planet.
will be looking at planets as well.
Yes. Planets in our solar system, and also planets that we call exoplanets, which are planets that orbit stars in the galaxies.
Do you think James Webb Space Telescope will help us discover life on other planets?
That is a difficult question. Life per se, I think it will be difficult. I think it's not really something very likely. But because of this capability of looking at the atmosphere of exoplanets, and also, for instance, the moon of Jupiter's, I think we could learn a lot about whether the elements are present that could sustain life. So if we look at the planets, that it's what we call the habitable zone. So at the right distance from its own stars to have temperatures that are not crazy cold or crazy hot, right? So that's a temperature range that we think, okay, life could exist. And then we look at the atmospheres. And for instance, we see that there is oxygen, there is water vapor, there's methane that could give us a hint that life is present or is possible on that planet. So that's very exciting.
Wow, Giovanna, thank you. That was a lot of information, but I think it might be helpful if we went and saw the model of the James Webb Space Telescope.
Yeah,
Should
sure.
we do that?
Of course, let's do that.
Let's go take a look at this model.
Yes.
Wow. That is incredible.
Yeah.
Wow.
Yes.
It's quite impressive, even at this size.
It is. It is. It's a very striking shape, right?
Giovanna, thank you so much for talking to us today.
It's been a pleasure.
It's really inspiring that a little girl who looked up at the stars in her hometown ended up working on the world's most powerful space telescope.
Yeah, it's very exciting and was very fortunate. Yeah.
Thank you so much.
Thank you. Thank you for the opportunity to talk to you.
If you're looking for more astronomy educational resources, check out ESA Education's Teach with Astronomy webpage, and keep an eye out for more videos coming from ESA Education.